Hi guys, Diogo Marcos. In this video I will show you everything you need to know to do a full data science project applied to a real world problem. Let's get started. Right, so now open up your VS Code and you're going to create your project folder. In my specific case it's chess project 2. In order to see just that specific folder in the workspace, what you do is add the folder to the workspace. That way, when you open up your VS Code, you only see this specific project, which is the one that you are working on. Then inside of this, you're going to have a couple of things that we need to work on. We're going to have a folder called data, and inside data, we're going to have raw, processed, visualization, and logs. Inside raw, the first folder is chess.com games, and the reason for it is that we are going to retrieve information from the internet, specifically chess.com. And think about it, in the future we could retrieve information from many other sources like Chess and so on. So in this specific case, because we are just retrieving information from chess.com, I just have this folder here. And inside this folder, I'm going to have a folder for each of these three players. So for Magnus, for Hikaru, and for Fabiano. So again, data, raw, chess.com games, and all the three players. Inside of each of these three folders, the PGNs, the games that we're going to retrieve from chess.com, we're going to enter here. After raw, we're going to have a second folder called processed. And inside processed, we're going to process two things. We're going to process the PGNs for each of the players. And the same thing, you're going to create another folder called CSVs and then other three folders for each of the players. So again, inside processed, we're going to process PGNs for each of these three players. We're going to process CSV for each of these three players, okay? And then we're going to have another folder called visualization. And this is the folder that will have the end files that we'll need for them to use with a dashboard, so that in the end with DataLens, we can see the graphs. I also have another folder here called logs. And this is in between processes. When you like processing a data frame and want to know if there's some games missing, those will go directly to the logs. That way you have a file saying, let's say game number 4 is missing or game number 43 is missing. Those will go into the logs. Then you're going to have a folder called external. And inside of external, create a folder called Stockfish. And inside of that folder, you're going to copy the file that you downloaded from Stockfish. You're going to copy and paste all those files directly inside of this folder. So external, Stockfish, and inside of Stockfish folder, you're going to copy all those files that you downloaded from the Stockfish website, and you're going to paste those directly inside here. And then I have another folder called modules, and this is the modules folder that has all the Python files that we'll be working on. So the main classes, and then you have another folder called tools for specific calculations and other separate processes. I specifically have a separated folder called tools, which are standalone Python scripts that I use specifically for other types of calculations and other stuff. But these are the main files. So main files, and then a separate folder called tools that has all the files that you need to do some other calculations besides the main files. So then I have another folder called supporting documentation, where essentially it's a placeholder for all the information in regards to the project. So a README file, Excel files, and so on. All the information in regards to your project goes here. And note specifically here that I've separated the app.py from the modules, because this is the orchestrator file, meaning we're going to run all the stuff that we have here directly from one file. Alright, with that out of the way, let's get started. Alright everybody, moving on to the init file. The init file is a special Python file used to mark a directory as a Python package. So in our specific example, we are inside of modules, so it's a good practice to do this in comments. So our init file .py. So we are going to import classes for various functionalities. In our specific case, we are going to retrieve the data from chess.com. Then we're going to process it, and then we're going to manipulate the data so that in the end we have the end file so that we can work with DataLens. So the first step here, we're going to import classes for various functionalities. And we're going to say from .data retriever, we're going to import our class data retriever. The dot indicates relative import. It means that the data retriever is in the same package as the init py file, meaning they are in the same folder. So here in modules, see we have init, and the data retriever is in the same folder. This is what we are saying here. And we're also going to need from .data processor, same thing. We're going to import the class data processor. And finally, again, from data manipulator, we're going to import data manipulator, same thing. So essentially what these lines mean, we are importing specific classes from the modules directly, meaning they are in the same folder. And then this is also a good idea to include the version. So we might have different versions of the init file. So what we do here is, let's say our init file, its first version, it's 1.0.0. So this is the first version of our file. One note about the double underscore. These are known as magic or dunder double underscore methods and variables. They are essentially used to interact with Python's built-in behavior. We have init to initialize the object. We have version like this one, that means literally the version. And we also have strings to represent string representation of the object. All right, we're done with this one. Right, so let's start working on our app py file. This file is the one that we will be using to orchestrate all the other files that we will be coding in a bit. So the whole idea is, instead of you running each of these files individually, you're going to run just one file. So with that idea in mind, the first concept is to import the classes that we will be needing from each of these modules, so that from the app.py, we are going to work with those files here. So the first step is to import the modules. So from modules, import data retriever, data processor, and data manipulator. Then we're going to define the file paths and player names for retriever, for processor, and for manipulator. For retriever, we're going to create a dictionary called, say, source config. And inside of it, we're going to have key value pairs. In our specific case, we're going to have output folders. And we're going to have players, where each player, the key, it's going to have a value, meaning its folder. So you're going to have Magnus Carlsen and the folder path. I'm just going to copy directly this here from the path. The second one is Hikaru. Again, just copying the path directly. And finally, the third one is Fabiano. So essentially what we have here is an inner dictionary inside of another dictionary. So in regards to our players, we just put in the names. So we have a list of the players. So you just can copy those directly here. So Magnus Carlsen, Hikaru, and Fabiano Caruana. Just missing a comma here, and we're good to go. So again, we have another dictionary called source config, where the key is output folders and the value are the players. But inside output folders, we created another dictionary so that we can map the name specifically. So the key Magnus Carlsen has a value which is a folder. So the Magnus Carlsen 1 we created before, and the same thing for the other players. Now, an important thing here when you're naming these are specific names used when we are going to retrieve the names from the players from chess.com. So specifically there, Magnus Carlsen, the name of the account is Magnus Carlsen, but the name of the account Hikaru Nakamura there is Hikaru. This is why I have these names here specifically. Right, so let's move on to processor. So here initially, again, we are retrieving the files directly from chess.com, attributing those to each player so that inside of each player's folder, all the games will be downloaded directly to there. And then we're going to need a directory for processing the PGN files. So let's call it PGN directories. And inside this dictionary, this is a little different from the first one. The first element here is the path to the destination folder where the process PGN's files will be saved. And the second element is the name of the combined PGN file that will be created in the destination folder. So essentially here we are downloading like a bunch of files, like 10 years worth of files. But here, when we're processing it, it's like for all those files for, let's say, for Magnus Carlsen, now we just have one. So here, this is what we do. I'm going to simplify this in the beginning before we have like a bunch of gibberish directories here for you to understand the idea. So we're going to call this PGN directories, and then we're going to create the dictionary. But inside the dictionary, here, this is the initial directory, and this is the key. And the value is a tuple where it's going to hold two things. It's going to hold the new directory, where the file is going to go, and then the actual name of the file with the extension. So when you copy the directories here and add the new files, this is what you're going to get. So here, again, this is the initial directory, so Chess.com Games Magnus Carlsen, and now we have a tuple where it's going to hold two things. The new directory, note here that it's not raw anymore, it's processed, and now this is the name of the file. And this is comma, and then we're going to do the same thing for the other ones. So again, for Hikaru Nakamura, so the first key is in raw, Hikaru Nakamura, associated with a tuple that holds two values inside. The first one is the directory for Hikaru Nakamura. Note that it's different from the first one because it's not raw, it's processed. And then it has the value for the combined path of the file. And then we're going to do the same thing for Fabiano. So essentially what we are saying here is saying all the new PGN directories is going to take all the files from the initial one that we have retrieved and then output all those files into one single one called what we have here. So one for Magnus, one for Hikaru, and one for Fabiano. Alright, as for the manipulator, this is what we're going to do. We're going to take in the PGN files. So here in processor, essentially we took in all the files from source config, all the raw files, imagine like 10 years worth of games for each player, and then combine those directly into one. And now for manipulator, we're going to input those PGN files and going to add information specifically to those files. We'll work later on exactly what we're going to do to those files, but essentially it's the combined games sorted with adders that we are going to add specifically to those PGNs. So again, we're going to create another dictionary. Let's call it input PGN files. And it's equal to, we're going to have the players as keys and the directory file as values. So here, we're going to do Magnus Carlsen. We're going to have a directory there. I'm going to get that in a bit. Same thing for Hikaru Nakamura. I'm going to have a value associated with it as well. And the same thing for Fabiano. Caruana, with a value associated to it as well. Just going to copy the values directly here. So these are the paths that I have, because it makes it easier when we are looking back to see where we are. Look at this, we have Magnus Carlsen combined games, so we have like initial games, goes into here like by date, then have combined games. And here it's combined games sorted, so we're going to sort the games and add adders to those. So we're going to have one file that's combined games, comes from before, it's going to be sorted, and then we're going to add adders to it. And we're going to do the same thing for the other players. And now we're going to output those files specifically to data frames, or more specifically CSV files. Until this point, we have only been working with PGN files. We're going to download the PGN files from chess.com. We're going to combine those into one single one. We're going to sort those and add adders to those. And now in manipulator, so this is the first step, input PGN files. And now we're going to start outputting files. And the first one is going to call output data frame files. So you can call the file for each player called process data frame, and it's another dictionary, so key value pairs, just as before. So the keys are the players. We're going to have as values the path. Note here it's processed, CSVs too, so processed, CSVs here, and then the name of the player, and inside of it, even though the file was not created at this point, but we are going to assume as it is, because it makes it easier when to looking at things to remain organized. So now it's magnuscarlsenchess.com processed data frame, what we have here. And we're going to output a couple of more files. The first one is logs that are going to go inside here. So same thing, so output data frame file logs for all three players, and all those chess process data frame logs, if like missing games or missing headers or missing time controls from each game, we're going to see those directly in the logs folder. We're going to also need another dictionary for blitz. And what I mean by this is, because Hikaru was accused of cheating in blitz games, we're going to process the data frame files by blitz, meaning we're going to filter each data frame by blitz. And for that, we're going to create a new CSV file. So we're going to have a new output directory. Let's call it data frame files filtered by blitz, again for all three players. And in the directory, notice that I keep adding information to this so we know what we are doing here. So now it's magnuscarlsenchess.com filtered data frame by blitz. So I just added this specific part here so that we know at each stage exactly where we are. You're going to also need a couple of more output directories, and I will explain to you what these mean. The first one is streaks unordered and ordered, and I will explain to you later on what this means. But essentially, we are taking in from all those blitz games, we're going to process those and find the streaks that the player did in all that sequence. So let's say he played like a sequence of 4 winning streaks, and so on. But we need, for statistical purposes, and I'll explain to you later on, the unordered version of this and the ordered version of this. So essentially we are looking at two different files. So I called it 3A because it's referring to the same type of like stage we are. So it's a process streaks unordered, and the other one is process streaks ordered version. So this is all we're doing. And then for each streak, we're also going to need the details specifically to that streak. Meaning, let's say you played a streak of 4 winning games. We need to know specifically what were the games of that 4 streak represents to. So you're going to have a separate file for each player for each streak. And then we can see for like streak, let's say streak number 2, we found that the amount of games and the players that the player played with. This is why a pandas and data frame manipulation is important, because we are using several instances of those techniques in order to accomplish your specific goals. And lastly, we're going to need a dictionary for the winner games. Alright, and now that we have our folder path specified, now we're going to define the main function. And inside here, we're going to do 3 things. We're going to initialize the data retriever. We're going to initialize the data process with pgn directories, and we are going to initialize the data manipulator with the data frames and file paths. Then here we are creating a new instance of the data retriever class, passing source config as an argument to its constructor. So to do that, it's data retriever, and then passing in source config as an argument to its constructor. And then we are going to need to invoke process data, which is a method that we'll be creating on the retriever object. The idea here is that the data retrieved by retriever is processed according to the method's functionality. So to do that, we're going to do retriever dot process data. And now we're going to do the same thing for data process with the pgn directory. So it's processor equals to data processor and passing in pgn directories. And then, same as before, we're going to invoke a method on process object to process all the pgn files. So it's processor dot process all pgn files. Note here, you won't be seeing this as yellowish in the beginning. It will be like grayish, a color like this, because the methods that I created are already functioning inside of each class. But if they weren't, let's say it's like 1, you notice here that it's kind of grayish. It's going to say any because it's not created yet. And then we're going to need to initialize the data manipulator with the data frames and file paths. The whole idea to the data manipulator is that we don't need to return anything here, just process the file and save it in each different version. And the same thing holds true for the other one. So the whole idea here is, besides the file paths that we have here, all we are doing is essentially creating an object of each class and then calling in a method of that object to process all the stuff in there and then save specifically to those path folders. So here this is kind of a larger one. I'm going to copy the code here and explain to you as we go along. So this one, we'll call it manipulator, same thing as before. We are creating an instance of the data manipulator class and passing in as arguments all the input and output folders that we created before as arguments to its constructor. And same as the other ones, we're going to invoke the process data frames method on the manipulator object. And finally, to complete this, we're going to need if name equals main, then main. Every Python module has a special built-in variable called name. When a Python file is run directly as a script, the name of the value is set to main. If the file is imported as a module in another script, the name will be set to the module's name. It will be like the file name without the py extension. The if here that we see here essentially checks if the script is being run directly and not being imported as a module, same as the other ones that we see here on top. So if the file is being executed as the main program, the code inside of it, this is what we have here. We are creating objects of the class retriever, process, and manipulator, and invoking specific class methods on these objects. The simplified way to looking at this is, let's say you have a specific file and you have a main function in it. If you import that specific file to another one, it will only run the stuff that is inside main, not the stuff outside of it. Alright, we are done with the app.py file. In the next one, we will see how can we retrieve games from chess.com automatically. Alright everybody, we are moving on to data retriever. So now we're going to take information from chess.com. So how does that work? When you go to api-chess.com, there's a structure that you put in the URL so that it will allow you to retrieve this JSON file. This is how this works. So you have api.chess.com, then pub as in public, then player, and then the player name, and then games and archives. So if you think about this URL structure, the only thing that is different, meaning for each player, is this name in the middle. This specific one is Daniel Naroditsky, but it could be Hikaru, it could be you, it could be any other player that is listed on chess.com. When you do a specific game, so let's say you do this one, let's copy the game here, and put PGN in front of it, it's going to download immediately the game. Note here that it downloaded the specific game. So now that we know the structure specifically to how to operate with the API from chess.com, how does this work seen from VS Code? Well, in general, if you want to know specifically if the API is accepting requests or not, I'll show you the snippet of the code. So this is what we do. You do import, and then requests, and then the URL equal to, then just copying directly the URL that we saw here before from Daniel Naroditsky. Just get it here. All right, and this is what you do. You're going to define the headers equals to, and then user agent, and then this is Mozilla 5.0, and you're going to elicit the response. You want to get the response when you do the API call. So it's response equals to requests dot get, and then URL, then headers. This specific headers, like the parameter here, this happens to accept this variable that is called headers, so we're going to call it the same name. Note here that if this was headers 2, we just change it here. See how this is the same thing. Alright, so headers, headers. And now we're going to print the response. And when we do that, if we get a 200 response, which is the case, it means that the URL is accepting to go there and retrieve the archive. So to retrieve the information, we're going to use URL lib from Python. So this is how it works. So we're going to import URL lib dot request, and we are going to need to do file operations with our operating system, meaning creating directories and so on. And to do that, we're going to import OS. Right, so now we create a class data retriever. And you're going to have a couple of functions inside. So the first one is the constructor. So def init, then self source config. We'll get to this in a bit. Source config is this specific dictionary. We have output folders that is mapping the output folder to the player. So we have one for Magnus Carlsen, one for Hikaru, and another one for Fabiano Caruana. So I already explained this. Essentially, we have an outer dictionary here and an inner dictionary here. So the first key is output folders, and the values, the keys paired to the values, are players. So Magnus Carlsen, Hikaru, and Fabiano. But inside output folders, we have another dictionary where the key is Magnus Carlsen, and its value specifically, it's a directory. Same thing for Hikaru and same thing for Fabiano. So here, when we are retrieving the data, we need the player and we need a folder where the games are going to go to. Alright, so now we need def download player games. Again, self, player, and download path. We'll go through these in a bit, and pass for now. So next we need another function, and we'll call it retrieve data, where the whole idea is if the player is in the players list, it is going to assign that player to the download output folder path. If we have a player that does exist in the list, but we don't have an output folder to him, we're going to create one. So we're going to call this function, let's say def retrieve data. Self, you're going to pass for now. And we also need another function to validate the data, meaning after all that is being retrieved, we need to have some way of saying if the data has been successfully downloaded and validated, or if, let's say, data for player, I don't know, player Hikaru is missing or not downloaded correctly. So to do that, we're going to create another function called def validate data and pass for now. Right, and because we want to have a streamlined way of calling functions here, the whole idea is to create object and then to call main function from it. That's the whole point. So for us to do that, we already saw this previously in our previous example. This is why I commented this before. So the whole idea is retriever, so we create an object, and then we call process data from it. So in order to create the process data from it, the whole idea here now is that we need a way of, when we call the process data, in a way it's kind of a source manager, meaning it will call the necessary functions inside that retriever so that it can actually do that. So we can actually start with this one. So we're going to do def process data, and then self, doesn't take in anything. And here specifically we're going to do self retrieve data. So what we have from the previous function, this goes first, and then we have self dot validate data. So this is the second one. So we're going to retrieve the data, and then we're going to validate it. And now specifically here inside retrieve the data, this is the place that we're going to call download player games. So let's start with the constructor first. So it's self output folders equals source config output folders. We are interested in the output folders key from the source config dictionary. And we are also interested in the players. So self players equals to source config players. Right, so we can get this out of the way, and we are done with the constructor. Now let's move on to validate data. So we're kind of going this like from the end to the beginning. So to validate the data, essentially what we are asking here is, for a specific player and a folder, if they exist in the output folder, like the items that are inside, you're going to print that the data has been successfully downloaded and validated. If not, you're going to say that the data for the player is missing or not downloaded correctly. So to do that, we're going to do for, because we have 3 players, we need to iterate. So it's player, then folder, in self output folders, because this is a dictionary, so it's items. If the folder exists and it's not empty, it means that the data for the player has been successfully downloaded and validated. Otherwise, the data for the player is missing. So if os.path exists, folder, and os.list_dir folder, you're going to print if data for player has been successfully downloaded and validated. Else, you're going to print data for player is missing or not downloaded correctly. Right, so we're done with this one. Before validating the data, so one step behind again. So the whole idea now is we need a method that checks if the player has an entry in the output folders directly. And if that player has a corresponding folder path, it retrieves that path and checks if the folder already exists. If the folder doesn't exist, it creates one using makeDirs, which is the method that we have available. So to do that, this is what we do. We're going to do for player in self players. If player in self output folders download path equals self output folders and then player. So what we are saying here is if the specific player exists here, you're going to create a download path for that specific player. If the folder doesn't exist but the player does exist in the list, it's going to create one using makeDirs. So we have download path. So if not, os path exists, download path, os makeDirs, download path. And finally, you're going to call download player game. So this is the place that we are actually going to retrieve the information to here. So self download player games player download path. So if we are outside of this, meaning the player is not in self output folder, so the player is not here, so let's say some other player, so we need to catch that condition here. So else print f no folder path defined for player, the name of that specific player. This is done. Alright, so now about the download parts. When you come here to apichess.com, note here that the URL is exactly the same thing for everybody. The only thing that changes really is the name of the player. So it could be Hikaru Nakamura, Magnus Carlsen, Fabiano Caruana, but everything else in the URL is the same. I'm actually going to copy the whole URL so that we can then use this here for any player that we define. So we're going to define a base URL, and then we're going to copy what we got there. And the only difference here is the player. So instead of just having one player, we're going to have player. That way, when we pass the player to the argument, we're going to define a base URL for that specific player. So now we're going to solve this in 2 steps. The first one is to read the archives and store these in a list. And the second step is to actually download the archives. So let's start with step 1. Read the archives and store these in a list. Step 2, download the games. Right, so let's start working on step 1. So now we're going to try to retrieve the list of archives. So to do that, we're going to do try and pass for now, except exception as E, and then pass. And here we're going to try to read the archives and store those in a list. If not, if that doesn't happen, we need to catch that exception and exit this loop. So now we're going to do with URL lib.request.url open base URL, the one we defined earlier. So I'll just copy that here as response. Archives equals to response dot read decode UTF-8 and archives list is equal to eval archives. And here specifically in the exception block, we're going to print F error retrieving archives for player, and then the specific exception E, and then we're going to return. Actually, I'm going to also add here a print. We can do that right now, so that when we are retrieving the games for a specific player, it's going to show that it's starting to retrieve the player's games. So we do that by just having like this little like control print here, so saying retrieving PGN games for player. So this is the base URL that we already saw that works when we are retrieving the files. The archives are then stored in a list format, which is then decoded into a string and converted into a dictionary using eval. If the retrieval of archives fails, the except block is going to catch the error and print an error message, terminating the function early. And here specifically is when we are starting to download the games for a player. So you're going to see retrieving PGN games for Magnus Carlsen, and then fetching the games, and then the same thing for Fabiano Caruana, and the same thing for Hikaru Nakamura. Right, so now here, if the archives are successfully read, we want to have a method that defines the file name structure and its download path. This is done before the try except. We're essentially going to define some rules for the URL and the file name for the final path to the file. Right, so now we're going to download the games. And to do that, because we have multiple players, we're going to do for archive URL in archives list, and then the URL is going to be f archive URL PGN. This is what this means. When we place PGN in front of the base URL, when we get here, essentially what we are saying is when we have this and I copy this here specifically, and I place PGN in front of it, it's going to download the specific game. See here, it downloaded the game. And we want to do this specifically for all the games of that player. So to do that, we have this inside of the for. But then we also need a file name that the file is going to go to. So you're going to have a file name, and you're going to do join. I'll explain to you in a bit what this means. Join archive URL split -2 and then finally the full path equals to os path join download path f file name pgn. As for the file name, when we downloaded the file has a specific name criteria. So it has chess.com, then Narodetsky, and the scores here, and then the date.pgn. We don't want that. We want a simpler version of this. And for you to see what I'm doing here, I'm going to copy this here because I have this prepared for you. So we want to have a way of splitting the whole thing, the whole name that we had before. And then you're going to take all the slashes from it. So here is api-chess.com, pub player, you're going to take all that stuff from it. And the only thing that we are interested in is the last two terms. This is what I have here, -2. So we are interested in 2010 and 06. And because we just have these like this, we want to join those specifically with this minus sign. So first we have this horrible name, then we split the whole name into a bunch of stuff, and we are just interested in the last two elements. And now specifically here in full path, we're going to put it, or better said, combine the download path with the file name and add its extension. So instead of having 2010-06, we're going to have that pgn. And the full path essentially joins those. And now here, this is where you're actually going to download the games. So you're going to do try, and then URL live.request URL retrieve, then URL, the game, and the full path. So then we're going to print f file name .pgn has been downloaded to the download path. And the exception, we're going to print here at f you're going to print here f error downloading file name pgn for player. And here specifically the exception. And finally you can have another print here saying print f and all files for player have been downloaded. So again here, we are creating an instance of the data retriever class, passing source config as an argument to its constructor. Then it's going to initialize the retriever object with the configuration provided by the source config. And then we're going to invoke process data, this one we have here, so that on the retriever object. And this method is going to process the data retrieved by the retriever according to the functionality defined in the process data method. And we did that here. So here essentially we are calling two things. So in the end it's going to validate the data. And before that, we're going to retrieve the data. And we already saw here that it's going to iterate each player through the players list. And if that player exists, it's going to create an output folder for that specific player. If the folder doesn't exist, it's going to create it for that player. The only exception is that when that player doesn't exist, it's going to say that no folder path is going to be defined for that specific player. So with that out of the way, it's going to call the download method for that specific player. And we see here that we do this in 2 steps. The first one is the base URL when you go to api.com from chess.com. And we also seen the rules for downloading a specific game where we add the PGN in front of it. So here specifically, since we are doing this in 2 steps, we are reading the archives first and storing those in a list. And the second one is to actually download the games. The interesting parts here is that we are decoding these into a string and then converting these into dictionaries. And here specifically the interesting part is that with URL, appending the /pgn downloads a specific game. And in file name, we're going to manipulate the file name that we are retrieving so that it's more in line and more organized with what we want. So instead we just have, like instead of a bunch of numbers, we just have date.pgn. And we do that here. So you're interested in the last 2 elements of the list. And then the file name specifically, we're going to add pgn to it. And then here is where the actually downloading of the files happens. So let's run this. Isn't that cool? So now we're getting the games for Magnus Carlsen, and then it's going to go through Hikaru and then for Fabiano. And we are seeing here the prints of all the games. This is going to take a while, but you see that this actually is happening in real time. Right, so we have just completed this, and we have like the validation here before. So we have the last player that we have downloaded the files. All the games have been successfully downloaded and validated. Alright everybody, now we're going to process the PGNs we retrieved for each player. PGN means portable game notation, and essentially it has a structure like this. So we have event, we have site, date, round, white, who played black, and then the result. There are some PGNs out there that don't have all this information, some have less, but for the most part this is the key structure that you will see. So you will see like the PGN file, this part is called headers, and then you have the actual game, so move 1, move 2, move 3, and so on. Now from here we'll revisit this PGN in a bit because we'll need to understand a couple of logic statements that we're going to do in a bit. For now, the first thing to do, we need to define the class. So the class is class data processor. And then we're going to define, same as always, the class constructor. And then here we're going to have self, then PGN directories. Remember, PGN directories from app.py was the place that we defined all the files for each player. So we have a space for Magnus Carlsen, and we have a combined file for Magnus Carlsen. And this comes directly from app.py. We take a step further. When we define the PGN directories, essentially what we are saying here is that the end file, meaning the combined file, is going to be in this specific folder. So remember, from the chess.com we retrieved all the individual PGNs and they went to the raw folder. And now inside of the processed folder, we're going to end up having a file, a combined file. This is what we're doing. We just took a step and just defined the file here, although it's not created yet. So what we are going to do now is create this file. So data processor, so we're going to need the PGN directories so that inside the data processor we can work with all its methods. So here we're going to do self, then PGN directories equals to PGN directories. Right, and now about the concatenation part. So how do we do this? So we need to define the method first. So def concatenate PGN files. And here as arguments, so you're going to need obviously self, this is self-explanatory. Then you're going to need a couple of things. We're going to need the input directory. You're going to need an output directory. And we're going to need the output file name. So now here we need to create the output directory if it doesn't exist. And to do that, we're going to do os make theirs output directory. and if it exists, do nothing. And we do that by passing the statement. So exist, OK, equals true. Right, so now that we retrieved all the individual files for each player, remember from chess.com, we retrieved all the files for Magnus Carlsen, all the individual files for Hikaru Nakamura, and all the individual files for Fabiano Caruana. So essentially, we now need to process the PGNs. The whole idea with that processor, we're going to combine all these files into one single one, and then add more stuff to it because we're going to need in order to make our assessments in regards to the initial claim. In order to do that, first we need to know exactly what is a PGN. PGN means portable game notation, and essentially it's a way of having in a file, specifically to chess games, information about that game. So we have a section called headers, you can see this between these brackets, and then we have all this type of information. Sometimes you'll find PGNs that have less information than this. Chess.com ones are very complete, but for the most part, this is the whole structure. So you have the headers part, you see this between the brackets, and then you have the game. So move 1, move 2, and so on. This is about each move. So move 1, one player played one move, and the second player played the other move, and then second move, third move, and so on. And the game ends when we have this part, so it's the end result of the game. And these chess.com games, they are always separated by 2 blank spaces. And this is going to be useful for us in a bit because we need to process these. So essentially this is what we have in a PGN file. So we have the other section pertaining information for that specific game. We have the moves and then the game ends. And then we have 2 spaces until we get the next game. So now here inside of data processor, we need to do stuff to the PGN games. And the first thing to do is we need to combine the games. In order to do that, we need to understand first how we define the PGN directories. So here in app.py, we defined PGN directories yesterday, and we have a couple of things here. So we have this initial dictionary, and we have the first folder directory, which was raw, meaning all the games for Magnus Carlsen are in this raw folder. Same thing for Hikaru and same thing for Fabiano. And now we're going to get a file, a combined file for each player in the version of this is where it's processed, meaning we have a raw folder and now we have this process folder. And this process folder will end up having this file that we haven't created yet for each player. And this is what we're going to do here specifically in data processor. So first we need to import a couple of modules. The first one is import OS, so that we can use the system in order to create file directories and so on. Glob is a module that finds all the path names matching a specific pattern according to rules. Let's say you have something like this. This is why we use glob for, so looking for this specific pattern. So this is why we're going to need that. And now we're going to need to import also regular expressions. It's going to be useful because we're going to read all the headers and we are looking for specific patterns that the header has. And there are a couple of things that we're going to need. I'll explain to you in a bit some regular expressions, but the whole concept to this is we're going to go through all these files and sometimes we're going to just need to find, let's say, this part or this part. And for that, we need to use regular expressions. The code kind of looks weird, but you'll get used to it. It's very useful to do these types of operations. Right, the next one, we're going to need to import datetime from datetime. And this will allow us to do operations with dates and time. Specifically here, we are interested in ordering the files, remembering getting the files from the earliest one to the latest one. And in order to do that, we are going to need to do operations with this specific part. We have the end date, we have an end time, we have a start time. We're going to need to do operations with this. Then we're going to need to also import chess PGN. This will allow us to do operations with the PGNs. You're going to need to import pandas as PD. It's essentially to do data frame operations. And then we're going to need to also import from typing, import union and dict. So what does this do? So the union type is used to specify that a value could be one of several types. We use this to avoid warnings in compile time and runtime errors. For now, we're going to define the class data processor. So class data processor. And then we'll start off with a class constructor. So def init. And then here we're going to need the pgn directory. So besides self, you're going to need pgn directories. We can take this off, and specifically here we're going to do self.pgn directories equals to, let me copy this thing over, pgn directories. So pgn directories, we defined those specifically in app.py when we are interested in creating a file combining all the retrieved files from chess.com. Remember that for each player, for Magnus, Hikaru and Fabiano, we put all those games in raw. And now we have an output directory. So this was raw, and now for processed pgns. Now we're going to enter here specifically for this player, and now we're going to output a file, a combined file for that specific player. Same thing for Hikaru and same thing for Fabiano. So here in data processor, we are going to pass in the pgn directories for each player whenever we are processing that specific player. So we're going to process Magnus, we're going to process Hikaru and Fabiano, and we need the pgn directory so we can fetch the specific directory for that specific player. And then the output directory where we will put the output file for that specific player. So now we're going to need a couple of functions before doing all the code for each individual one. And now we're going to need a couple more functions. The first one is to concatenate the pgn files. So def concatenate pgn files. And then here besides self, we're going to need an input directory, an output directory, and an output file name. And for now we're going to pass. You're going to need another function to parse the game. Parsing is just a fancy word just to say to go through all the stuff. So def parse game, and then self, and then game. So essentially we're parsing each game one at a time. And now we need a function to also sort the pgn games. Remember that just because we retrieved all the files by year and month, it doesn't necessarily mean that inside of each pgn they come in order. Here specifically in Magnus, note here that the start time is 1813, but then the start time on this one is 1812. So we need to make sure that we have all the files inside of each pgn sorted by order for the first one up to the last one. So to do that, we're going to sort the pgn. So def sort pgn file, then self, input file, and output file. Then for now, we're going to pass. And now for the next two functions, I need to explain what we are doing here. Remember that the accusation made by Kramnik to Hikaru was that he cheated in blitz games. So here, it doesn't necessarily say in the game if the game is blitz or not. So we need to make sure that we have that specific information in the headers of the game so that later on when we are analyzing the streaks, the games, we are doing that because we have all games ordered by the oldest one up to the most recent one, and because each header has blitz in it. And in the future, if we want to also analyze if the game was played online or offline, we also need to add another tag here saying if this specific game is online or offline. This is not relevant here because all chess.com games are played online, but let's say you have like the combined pgn file for all the games that, let's say, Hikaru played, both offline and online. So we would need to have in the header a way of accounting if that game was played online or offline. Nevertheless, we're still going to do that here specifically in this data processor file, so that later on when we decide, let's say, to import further games, let's say played offline as well, we can account for those. So in the end, we can have a table with all the games, and then we have like a column saying these games were played offline and these games were played online. So now about the time control. So the time control, we have a couple of them. We have Daily, Classical, Rapid, Blitz, and Bullet. Daily takes you like a bunch of days to complete the game, that's the whole idea. Classic has a specific structure, and then the games start getting shorter in time control, meaning like the bullet ones are the fastest ones. So we need to make sure that we then assign a specific tag for each game, knowing if that specific game was rapid or classical or daily or whatever the case it might be. So here we're going to do def get time control, and then self event header time control header. Again, we're going to pass, and we're going to do the same thing for the game if it was held online or offline. So we can do def get place self site header event header and link header. I'll explain to you what I mean by this. So here specifically, when we're looking at a game, sometimes we have clues about where the game was held. So let's say if the site says chess.com or the event says live chess, or let's say the place has any particular information in regards to where the game was held, we can use that to our advantage. So let's say the event here, the name was, let's say, Tata Steel Classical Chess, and it was held somewhere in whatever place. So we know that that game was held offline. But if the event says or the site says chess.com, we know that the game was held online. So this is the whole point here. And also about the link. Specifically here, when you click these links, sometimes you'll see specifically for that player if the game was Blitz, if the game was daily, whatever the type of game it was. I found that in these types of links, for the most part, if it's daily, you will have daily here. So here, these are the clues that will tell us if this game was held online or offline. Specifically here, note that I'm making sure that we are naming this in accordance to the PGN file that we have, because it will make it easier for us to make an assessment. So site header, meaning the site header here. So if it's chess.com, let's say it's a Tata Steel or any other place, we can then assess if that was online or offline. So this one is kind of obvious, and sometimes it isn't if you're not a chess professional. So for the most part, we will be dealing with this site tag in order to assess if the game was online or offline. Same thing for event, and also about the link. These ones are obviously directly a clue from chess.com that the game was held online. And now we need a function to add the headers to the PGN. So we get the time control and we get the place, and then we add those headers specifically to the PGN. So in order to do that, we're going to do def add headers to PGN. And here besides self, we're going to need the input PGN. And then we're going to output the PGN with the added headers. Here for now, I'm just going to pass. And then, because these are so many games, we have thousands of games for each player. Specifically for Hikaru, it's plus 50,000 games and more. We need to make sure that we can have a contribution from each game, and that specific game not having, let's say, missing information, and then we can't use that specific game. So in order to do that, we need to analyze the PGN for missing time control, and also some specific unique events of that game. Let's say it's missing ELO or missing any other information that might be useful, so we need to account for that. So for that, we need to create another function. I'll call it, let's say, analyze PGN for missing time control, the specific one, and pass in, besides self, the input file, and the output CSV. We're going to output to a CSV the specific missing time controls we have. Because remember, if we have a text file, it might not be that easy to read, because you might have, let's say, 5,000 game controls that are missing. And it's when it's CSV, it's easier, because using Excel or even actually Python to do that, you get one by one and you assess exactly what's going on with that specific game. So pass for now. In the next one, since these are so many games, we need kind of this maybe redundant method, but it's useful. The whole idea is that we want to make sure we only have unique missing events and not duplicated ones. if we have some sort of error in our code, we're going to see this specifically because in each individual game, we're going to see, okay, so this is duplicated, so what happened? So I needed to create, when I created this program, I needed to create this kind of fail-safe measurement in between when we are doing our programming so that we can assess specifically if we're doing something wrong or not. So if this turns out to be correct, essentially we are just extracting unique events that are having some missing information from the headers. So def extract unique events, self and file paths. And finally, we need a function to process all the PGN games. Remember that the whole idea to have this simplified is that you create an instance of the class and then process all the stuff. Essentially just calling one method specifically from that class. So this is what we are doing here. So def process all PGN files and then self. Right, so now we are ready to go. Remember, keep in mind the end goal of what we're doing here. The main goal of class data processor is to provide us with a PGN file, a combined PGL file that is ordered and that has edit tags in accordance to the analysis that we're making, specifically edit time controls, edit places if it was held online or offline, and making sure we don't have duplicated information in it. Right, let's get started. For the concatenate PGN files function, we're going to create the output directory if it doesn't exist. If it does, we need to do nothing. So we do os.make dirs and then output directory, and the argument is exist OK equals true. So what this means is create the output directory if it doesn't exist. If it does, do nothing. Then we need to get all the PGN files in the input directory, and now we're going to use glob. So PGN files equals glob dot glob os path join input directory, and then we are going to ask specifically to fetch all the PGN files, so they have this specific extension. This means all files, and then that each file ends with this specific extension. And then we need to sort the files based on their name, which are in year and month format. So here we have the files like this, but we have like a bunch of them. So just to make sure, just a fail-safe measure that says some of these are not like changed. So we need to make sure when we combine all the files into one single one, they are ordered by each of these ones. So to do that, we're going to do PGN files sort. And now we need to define our output path for the file. You're going to pass in as parameters the output directory and the output file name. So to do that, so you're going to do output path equals to os path join output directory and output file name. And now we need to open the file in write mode and concatenate all the stuff, all the files into one. So to do that, we're going to do with open output path in write mode encoding as UTF-8 as out file. Essentially, it's output file object. You're going to need to iterate through the sorted files. So to do that, you're going to do for PGN file in PGN files and with open PGN file in read mode. Again, the same encoding, just copy the stuff here. As input file. You're going to read the content of each file and then write it to the output file. So to do that, it's going to be out file dot write in file read. Essentially, what we are reading from the input file put that in the output file. And just to make sure we have a line between games, you're going to write a new blank line. So to do that, you're going to do output file dot write. This just means an empty blank line between each game. We can remove this here now. And let's move on to the next one. Okay, so we need to sort the PGN files. And to do that, we need to first parse each game. So parsing involves us using some regular expressions. And here specifically, we are interested in date match and time match, because we are ordering each file. And we already saw specifically here for Magnus Carlsen 1 that these are not in order. Most likely, if just making a rough assessment, but for the most part, I think this comes from max up to the minimum one. But we're not guessing here. We need to make sure this is done automatically. So we need a couple of things from here. We need the start time, so when the game started, and the date time, meaning that specific day. So just to make this clearer, we're going to just copy this stuff here so you can see exactly what we are doing. So we are interested in instances like this. We are interested in parsing this specific information from here. So how are you going to do that? So you're going to define date match equals to re search. And here now specifically, I'm just going to copy the code for you to see for both of them, and then I explain to you. I think it makes it easier. So what does this mean? So re search, it's going to look for UTC date. Because we are interested when it starts with this bracket, we need to have this backslash, otherwise you wouldn't read it. So we are essentially saying that take this literally and read this specific bracket. So then we continue what it's inside, so it's UTC date and UTC time, same thing for the other ones. And then we start with this part, so from here nothing too fancy. And now this is the key part. Inside of these brackets, we have these slash Ds, and these essentially mean like the number of digits that we are looking for. And these are separated by a dot. Note here we have 4 digits, 4, then 2, then 2. So we are looking for this specific pattern. And again here, in order to read the bracket, because we are interested in reading specifically this bracket, we need to have the slash before. So then obviously we need the game. So use this logic for date match for that specific game, and do the same thing for the time match. Right, so now you might be asking, okay, so we found the match, now what? So if that is true, so if date match and time match, we need to use date time now, and date time has an issue that we need to address. In order to use date time, the dates need to be separated like this and not like this. So we need to do something with this in order to separate that. So to do that, you're going to do date string, then date match dot group 1, then replace the dot with a minus. So the group 1, what this means is inside this part we are interested in this part. This is all this means. If it was 0, it would mean all this stuff. We are just interested in this specific element. So date string, date match group 1, replace. So here you're going to replace this one with this one. This is what we're doing. So when you pass the information to date time, you're going to have a representation of this. Instead of having points, you're going to have minuses. And here we're going to do the same thing. We're going to say that we are interested specifically for time purposes. We are just interested in this specific part. Now here's the logic. If both are found, we want to return a tuple with a parsed date and time and the game. And we also know that we need the date in this specific format so that we can use it with date time. So here we now are going to return. So if this is true, we're going to return date time strip time, and then let me just copy this stuff over. So what does this mean? Strip time is used to convert a string that represents a date or time into a data frame object. This will allow us to perform operations on date and time. This is the whole point, because we needed to compare, we needed to sort, so we need strip time in order to do that. So we are passing in the string with the information that we are interested in, and we're passing in directly that to date time in the format that it needs in order to perform that specific operation. And now that we have the content, now we need to sort it. So how are we going to do that? We need to look for patterns in these specific games. And one common pattern that appears here is that we have two blank spaces and then it starts with event. So we know that after this line, when the game ends, we have two blank spaces and then we start with this bracket and then event. And the same thing for the other ones. So two blank spaces, event, two blank spaces, event, and so on. And you might be asking, what if there are some games that have more than two lines? They don't, because they are already formatted when they come from chess.com. So all the files come from two blank spaces and then start with event. So we need to first separate each of these individual games, and this is the method that we are looking for. So two spaces and then starts with event. So again, we're going to use regular expressions. So games equals to RE split. And now here specifically, we're looking for a specific pattern. So R, and then two blank spaces. And then inside here, you're going to look for a forward situation that is going to happen. So this is how you do this in RE. So question mark equals, and then again, backslash, because it starts with a square bracket, and then the square bracket, obviously, and then event. And then here, we're going to pass in the content. So what are we doing here? We are reading the combined file, separating it into each individual game, and we look for a pattern in order for us to separate each game. And the pattern we've seen here before, it's two blank lines and then starting with event. And now here specifically, this is where we're actually going to sort the games, because now from the concatenated file, we have each game individually. So sorted games equals to sorted. And now here, specifically we're going to do self.parse game. We're going to call the function that we created earlier on so that we can parse that specific game. So game for game in games. And now we need the key in order to sort the game. So our key is lambda x and then x0. Or date time dot min. What this means is if the first game date and time could not be parsed for some reason, date min is used as a sorting key. So games with missing dates and time go to the beginning. So it's either one of these two. And now that we have the games sorted, now we need to write the sorted games to the output file. So same as before, with open output file in write mode, encoding same thing, UTF-8 as out file. And now for game in sorted games, out file dot write game plus two blank spaces. And we can actually add a print statement saying that the PGN file was created successfully. So why this underscore here? Remember that from parsed games, it does return none or return game. Now, I did this specifically here because in parsed game, we need to have a return. So the return is none or game. What's the point? The whole point to this is if no match is found, returns none for that date and just returns the game. So here we do this because we are just interested in the game, not the first return. Let's start with get place first. So we need to assess if the game was held online or offline, and to do that there are some matching keywords that we're going to use in order to assess that. I already have those copied here. So we have online sites and online events, and we're looking for keywords such as chess.com, chess24, and so on. We know that in all these instances, these events are always held online. And because, particularly in time control, we might be dealing with many types of names and events and formatting, in order for us to have this formatted in a way for us that we have some degree of control over it, we need to make sure that everything is lowercase. So we need to make sure that we don't have chess but like the C capitalized. So to do that, we're going to lowercase everything. So we're going to do site header equals to site header lower. Same thing for event header. Same thing, event header lower. And finally, same thing for link. So link header equals to link header lower. Now, as for the type of games, we're going to need to deal with games that are daily, classical, rapid, blitz, and bullet. We'll address the time rules in a bit. I noticed specifically in the game, specifically from Hikaru, that whenever we have a daily game, this is the format. So in the link, we have daily there. And for the other ones, we just have live. So to address that, this is what we're going to do. If daily in link header, return online. And now we can use the online sites and online events. So what we are doing now is saying if any site in site header for site in online sites, return online. And we're going to do the same thing for events. So if any event in event header for event in online events, return online. And for the remaining cases, we're just going to return offline. So return offline. So essentially what we're doing here is defining online sites and online events. These expressions always lead to having online sites, and we have this for online sites and online events, meaning matching specifically what we have here and what we have here. And then to make sure that sometimes we might have some typo or anything like that, we're going to lowercase everything. So site header, event header, and link header, we're going to lowercase everything. Specifically to get time control, only pertaining games from chess.com, we are not interested in the event header, but are only interested specifically in the time control because it has information in regards to the type of game. But this is only specific to games from chess.com. And I will show you other games that I worked on when I made the first version of this. I retrieved other PGN from the players. And note here that the headers are not that well formatted like we have here. So note here we have the information from time control. We know that it's live chess because obviously it was held on chess.com. But this one doesn't say. So here specifically we just have event, whatever this is. We don't have the date that is complete. It doesn't say anything about the time control. It doesn't say anything about the white ELO or the black ELO. So we need to address these types of games. So here specifically we're not going to do that for chess.com. It's not necessary, but I did do it in the first version of the game. And I want to show you my logic to this. So essentially I created a dictionary mapping the event keywords to the respective time controls. And here specifically this is where the LLMs come into place. Because if you have something like this, now what does this tell you specifically about if a game is rapid, if it's classical, whatever the case might be? So for you to get an idea, I ran through all these single words. I got those directly to the LLMs so that I could then retrieve the specific time control for the game. So in order to make that assessment, this is where the GPTs and all that stuff comes into play. So I'm going to copy the whole thing here for you to see. So here was the work that I did specifically for each keyword. So whatever this is, I got it from rapid. So whatever this is classical. All these ones are blitz and also one. And I made sure going through each individual one so that I wouldn't miss anyone. So all these classical and so on. So this is a gigantic list that I have here that is matching specific games to a specific type of time control. We know that we don't need this specifically for chess.com, but we will need this in the future if you are interested in analyzing games that are offline and not necessarily held from chess.com. So now we need to go through all this dictionary and assess what the event type is. So we're going to do for keyword event type in event mapping. This is a dictionary, so items. If keyword in event header, we want to return the event type. I also noticed a couple more patterns happening in these PGNs. Note here, when we have this time control, what the heck does this mean? I noticed that these games are always daily. So we have two options to address this. We already seen that we can do this directly from the link, but if that's the case that it didn't have any of that information in the link, we know that because this is like this, we know it was a daily game. So for this specific case, we're going to do if time control header starts with this specific pattern, so it's 1 and then /. We want it to return daily. And now we need the fallback for any other type controls that we actually have information that is numerical and that it's easier to process. I already have the code written here and we will go through these together. So if time control, we're going to try a couple of things here. So base time string, we're going to time control header and split by plus. What does this mean? Sometimes we have games that appear in the time control something like this, 880 plus 5. So it's the incremental parts of the game. So we have like 5 minutes plus some seconds. So we want to split this part because we are not interested in that part. We are just interested in the first part. So if it is 180, if it is 300, or whatever the case might be. So when we do that, now this falls in between this if-else statements. So between 180 and 1, we know it's bullet. If it's between 180 and 600, we know it's blitz. And then it's rapid, and then it's classical. And we have this in a try except block. And we do this here because we just want it to continue. So now we need to return. So if we have something that any condition weren't met, you're going to return an empty string. So in order to add the headers to the PGNs, now we need to add each individual game to a games list and use the chess import in order to get those individual games appended to the games. So to do that, we're going to do with open input PGN in read mode as PGN file object. Now we're going to start with an empty list of games, and while true, we want to read the game. So game equals chess.pgn read game and the PGN file. If the game is none, you want to break. Else, we need to append. Right, now that we read the games, we have the games in the games list, now we need to output those games to an output file. So to do that, we're going to do with open output PGN. Remember that the whole purpose of class data processor is to return a PGN file that has all the added information for that specific player as output file. Okay, now we can iterate over it. So for index game in enumerate, because we are interested not only in the value but in the index as well. So instead of returning, let's say A, B, and C, it returns 0A, 1B, 2C, and so on. So here enumerate and then games, because this is what the purpose of this is. So games, game headers, ID equals string index plus 1. What we are doing here essentially is, while we are outputting the game, we are also adding an ID to it. Think about it, we have 50,000 plus games from Hikaru. If we have any other source of information that is missing from game 47,000 something something, we have that specific index. This is the whole point to this. So with open output pgn, we need to enumerate because we're then going to add the ID to it. Right, so now we need a couple of things. The first one is to retrieve the site header and link header and event header, and if those are missing, return an empty string. The whole idea is, remember that we are adding headers to the pgn, so we are retrieving the information from site, event, and link, and in any case, if any of those are empty, we're just going to retrieve an empty string. So now we're going to address the place and the time control. So game.headers, and now place, the one that we are adding, if it was held online or offline. Now it's self get place, which is the function that we created before, so get place, and now we're going to pass in site header, event header, and link header, so all these three. So site header, event header, and finally link header. And now we're going to do the same thing for time control. So notice here that these games have time control like this. And I don't want to remove this, but what I want to also add is a tag that says time control, but with the time control specific to the game. If it's classical, if it's rapid, if it's blitz, whatever the case might be. So in order to do that, we're going to create a new tag called time_control, and it's going to hold the type of time control that the game was held in. Remember, we want to keep this one. We just want to add a new one with a different instance, meaning if it's a rapid, classic, or blitz, or whatever the case might be for that specific game. So we're still going to retrieve this one, nothing different from the other site headers. But now specifically here, this is what we're going to do. Because we created the get time control, we're going to use this now and do self get time control. And now, again, same as the other ones, we're going to pass in event header. And because this just needs event header and the time control header, these are the only arguments that we are passing specifically to this one. So now, because we had all that trouble in regards to finding the time control based on the event header, if we found information in regards to classical blitz or whatever the case might be, we're going to assign that specifically to our new time control header tag. So if time control, if that's true, then game headers, time control. We're just going to modify this a bit. Instead of time control connected together, just add another score, control, that is equal to whatever we retrieve from that initial gigantic block of text. If it's saying if it was rapid, if it was classical, it was blitz, or whatever the case might be. And now it's about to just output the file. So to do that, we're going to do output file dot write as a string name game output file. We want to just add 2 blank spaces after it. So dot write /n/n. Now we're interested in analyzing the PGN for missing time controls. We're going to need an input file, as we have seen, and an output CSV where we'll be outputting any time control, because remember, we are dealing with thousands and tens of thousands of multiple games. It will make our lives easier to assess exactly where the problem is using a data frame format, essentially. So we're going to start with the missing time control list. And with an empty game count. And now we need to address current game. Now, current game is a dictionary that can temporarily hold information about the current game being processed. And we're going to have 2 keys, ID and event. Both ID and event can be none. So none, none. But we also need to specify other types of values besides none. And this is what this dict comes into place, where essentially you are saying that the values can either be none, int, or a string. So with this out of the way, now we can read the input pgn file and read it line by line. And in order to do that, we're going to use with again. So with open input file in read mode, encoding again UTF-8 as a pgn file object. For line in pgn file, if line starts with event like this, we know that we have a game. So game count plus equals 1. So we know we start with an event, meaning it's a game, so we're going to count, to increment the game counter. And we're going to add the ID to it. So current game, the ID header, and now we're going to pass in game count. And the current game specifically, we want to read what's inside of the event part. So to do that, we're going to do current game, start with the event header, and then we're going to use regex again. So re.search, and there's this expression that search for everything inside quotes, and this is how it is do. So r, and use this dot plus symbol. What this means is it's going to search everything between quotes, and obviously we need the line here. But this comes in groups. This is all of it. We're just interested in group 1. So here it's group 1. Now, if line starts with time control, current game is equal to ID is equal to none, and event is none. So if this is not the case, so the other version, meaning we are going through a game, you go all through all the stuff, and now we reach an empty line. If that's the case, we need to address that here. So elif line strip equals, it's an empty line, and the current game has ID. This means it's the end of a game. Remember that this is not like one game and you run one line. You run all the lines from one game. So while you are inside for, so while you are reading the specific game, you go for, but line by line. So you go this line, you go this line, you go this line, and so on. So it goes through the first line and assigns an ID. So when we get here, meaning we already have an ID to that specific game, and the line is empty, then this is telling us that we have reached the final part of the game. So if current game ID is not none, this is the end of the file. So this is a specific case where we want to assign missing control and append it to that initial list. And now, because we have just appended that, we need to go to the next game. So current game, we're going to reset ID and event. Need to copy the stuff here again. So again, we open a game, we go through the first line. If the line has event, we're going to increment the counter, and it's set as ID here. So then we're going to find in event if the event part has information in it, and we do that with regex. So we're going to find if the event has this part. And because we know that earlier on we addressed every single instance that appears here in event, assigning a time control to it, this means that it can go through the next line. So ends the if-else statement and goes to the next line. And as we move along, when we find the line that has time control, this means that that specific game has a time control assigned to it. So our current game, we're going to reset ID and event. And again, it's going to go to the next line and the next line and so on until it reaches the end. So that specific game, we already know that it has an ID and that the line now is empty. So what this means is that the game has ended and we are going to append that game to the missing time control once. And now we need to write the output to the CSV file. So with open output CSV in write mode, new line equals empty, encoding equals UTF-8 as CSV file object, and now field names equals to ID, the ones that we retrieved, so ID and event, and writer equals csv.dict writer, pass in CSV file, and field names equals to field names. So just get the equal here. And now writer dot write header. And now we end with a for loop. So for game in missing time control, writer dot write, we're gonna do row by row the game. So from here we're going to end up with a CSV file like this. Initially it wasn't like this at all. It had like a bunch of IDs and a bunch of events. So now here, just for you to show, we're going to do these files again right from the get-go. I'm just going to show this specifically here. This is what we want to end up with IDs and event with nothing in here. So this means that this worked. So we have the file, so we have the IDs and the events being populated when we are missing in that gigantic dictionary that I created earlier on. But also we also want to return the missing time control number of events. So here we can also return len, this is out of the for loop, return len missing time control. So all this is doing is returning the name of games missing the time control header. Can remove the past now and move on to the next function. Here I also created this function with the whole purpose of, from all the players, I wanted to make sure, like in a unified text file, if no other information was missing, because it might be repeated. So I wanted to have just one file so that I couldn't like keep searching for the same thing over and over from different players. So this is a unified file from all the CSVs that essentially holds the information unique. And to do that, we're going to use set, because sets don't hold replicate information. And we're going to save this in logs, not inside of each of these PGNs. Just one log if that in fact is missing information from all these three players from each individual PGN game. So to do that, we're going to do all events, meaning from all players, equals to set empty in the beginning. And now for file path, in file paths, you're going to create a data frame, pd read CSV, file path, and events equals to df event. Actually can also drop NAs as well, and unique. And now we're going to update all events. So all events, update events. And finally, we're now ready to do the processing of all PGN files. This is kind of the manager of the whole organization inside of this class. So we start off with missing info files. We're going to run a for loop because remember we are doing this for each of the players. So for input directory and output directory and output file name in self pgn directories items, this is a dictionary. We want to concatenate all files, so concatenate pgn path equals to os.path.join output directory and output file name. And now, because this is an object of this class, we want to do self concatenate pgn files and input directory, output directory, output file name. In here specifically, so that we can have 1, 2, 3, 4 in the same file format that I have, we need to do kind of would be a technique here essentially, so that we don't end up with something like this. We just want 1 and we want it to be 4. This is the 4th file inside of the pgn. Remember that we created logs so that we can have information of each of the players, but this one specifically I found out having this CSV inside here, but this is pretty much the only one. Other than that, all of the other ones, all the logs, even the missing info is inside the logs. So it's just this specific one. So in order to address the name thing, this is what we're going to do. We're going to split the file name and extension. So we're going to do base name and extension, let's call it xt, os.path.split text output file name. And then we're going to remove the leading number and then the score if present. Remember, we just want to avoid something like this. So to do that, we're going to do base name without prefix equals to base name dot split, and I'll take the underscore here and then first position and then remove this one. That way we just only keep 1. So now we're going to construct the sorted output file name. So sorted output file name equals to f string now 2, and this is where the base without prefix comes in. So this part comes here, combined games with combined games sorted. And then we just need to add the extension. So all we are doing here is ending up with something like this. We have initial one, so combined games, and the sorted one, it's combined games sorted. So now that we have the output file name, we also need the sorted output path. So sorted output path equals to os.join output directory and now the sorted output file name. And now we need to sort the concatenated pgn file. So to do that, we're going to do self.sort pgn file and now concatenated pgn path and sorted output path. Right, so to address this, seem to be having an error here. So what I have here. So line 915. So what I have. Oh, just to remove this. Okay, cool. Right, so now it's time to add the additional headers to the sorted PGN file. Remember, we first combined the games. Now we are going to add information to it, so the headers. So to do that, we're going to do headers, added output file name, equals to F, so the third file in our series, this one. So we want to do this one. So we have the first one, games, then sorted. So we added 2 as a prefix and sorted as a afterfix. And now we're going to do the same thing with this one. So we start with this one, and we're going to add the 3 parts and the other parts after. So to do that, we're going to do f string, now 3, same thing as before. So base name without prefix, this one. Just get this to the side. Moving on, we're going to do the added output path. So headers, added path, not file name, output path equals to os.path.join output directory, headers, added output file name. And finally, for this part, we're going to do self add headers to PGN, and now sorted output path, headers, added output path. Now this is the part for the missing time control. So missing info CSV. So we are interested in creating this one, self analyze PGN for missing time control. And here as parameters, we're going to pass in headers, added output file path, and the missing CSV. So essentially we're going to write the CSV file. That's all we're doing here. So with this out of the way, let me just get this here. Here we go. And now we are interested in printing the missing count, so that we have, let's say, player, then games missing time control, number of games missing time control. So to do that, we're going to create a variable missing count is equal to self analyze games with missing time control, pass in as parameters headers, added output path, this one, and missing info CSV. And now we're going to print. So to do that, we're going to do print f base name without prefix again. Just going to copy this thing over. I already have this created here. So this is base name without prefix, so the name of the player. You're going to split this specific part and capitalize the name of the player. And then the missing count, and then games missing time control. So let's say Magnus, let's say 40 games missing time control. So now this is a specific part where you're going to extract the unique event to that specific text file. It has the unified information without repetition in one single file, so that we can see across the board all the names to the events or time controls or whatever the information that is missing that we need to work on. So this is output missing data txt in the specific case equals to, we're going to add the path of that specific file inside of logs. So just created one here, so just copy path. This is empty, but we can create one here. So R. So now that we have a path for unique events to a text file, we actually need to extract all the unique events from the missing info CSV. So unique events equals self extract unique events and missing info files. Actually, this makes more sense coming before. So like this. And now finally, with the open file, now we need to write the information to it. So we're going to do with open output missing data txt in write mode, as file. For event in unique events, you're going to write it, right? F here, and then we need these two, then event, and let's add this and some space after. Just going to delete all these files here so you can see that this actually works. So you can delete the logs as well, and this dude here is not doing anything, so nothing inside the PGNs for him and for Fabiano as well. Right, so just have the game just as before for each player, and for the process PGNs we have nothing so far. Right, so now let's run this. So app py, we have the processor here, process all PGN files. Let's go. It's going to take a while, but you already see that it's creating the first two files for Magnus. Alright, so we are done. And you can check here, we have the combined games for the player. All the games for Magnus, we have the games for Hikaru. Takes a while to open because it's 50,000 games. And we have the games for Fabiano. And then for the second one, it's the games sorted. Specifically, we noticed initially in Magnus that we had this initial one that was different with the different times and dates. So let's check this one. So we have this first one. So this is unsorted game, so 1813, and then we have this next one, which is 1812. And now the second version, when it's sorted, now this is correctly sorted. So we actually found another one. So we have 1811. And then we have this second one, 181152, and so on. So all of them are now sorted. And then we created another file for the headers. So as for the headers, so we have everything here, and we also added the time control. So this is the initial time control, and this is our time control. And also we added the ID for this specific game. That way, later on, if it's game number 40,000 from Hikaru, we know exactly what it's referring to. So we have the information initially from the game, we have the initial time control, and also we have the place if it was online or offline. And we have that for all the players. And finally here in the logs, we have the missing information. As you can see, you don't have any missing information from this player. So now let's move on to the next one. Let's start manipulating the CSVs. Alright everybody, welcome back. In this video, we're going to take care of the data manipulator. And the whole purpose is to taking in the PGN that we got before. So we created a PGN with headers, just like this for Magnus Carlsen. We added the ID, the place online, and the time control. And now we're going to take in this information and add a couple more things to it, and in addition create additional data frames. And I'll go one by one to explain what I mean. So the first one is taking in the PGN and converting it into a data frame. Specifically, we're going to add a couple of things. Note here, this is the final product that we are aiming for, and I will go through all these steps with you so that in the end we'll create one exactly like this. So the headers come directly from the PGN, nothing new here. So this is all information from the player, the outcome, the time control, and so on. But now we're going to need to add the ELO difference in terms of player. Remember that the acquisition was in regards to the players that he was playing against. So we need to know exactly the level, the ELO player rating that he was playing against, so we can then make a comparison and do our statistical analysis. So this has all the information from the PGN, number of moves, date, winner, and we are going to add in addition the ELO difference in terms of player. You can see here already we have a ELO difference, but we'll get to this in a bit. Now, the second one is in regards to filtering the data frame for Blitz. Because again, the accusation was that he was playing Blitz games, online Blitz games, so in chess.com. So we need to filter the ones that was like offline or was daily or rapid. We're just focusing specifically on the Blitz streaks that Hikaru did. So we start with the first data frame and then filter it by Blitz. The third file is the streaks themselves, meaning the players, when he played like the games, we need to know the consecutive streaks. So we know that one win is 1, the tie it counts as half, and loss counts as 0. So this was a streak. Specifically this one, the second one, it means he won 4 games and tied 1. And then he had a second streak of another time, and then another time, and so on. And in addition, because we will then need to have this sorted from min to max, we'll create a 3b here. Note that I have 3a and then 3b. It's the exact same thing, it's just a streak that is ordered. So what I mean by this is, instead of having 4.5 and 2.5 and like a bunch of numbers here, we have like a ton of them here. Essentially the whole thing to this is just sorted. So we have the 2s, the 3s, the 4s, the 5s, and then the last one, whatever the number was. And then the next file is in regards to the streaks themselves. I call this process streaks details. So we have the first streak identified by the IDs, and you can see that the IDs are consecutive here. See here we have 12, 13, 14, 15, 16, and then we have a break. So this means that we have a next streak coming up, and so on. Here we have the opponent's elo, meaning we know the elo of the main player. We are interested in knowing the elo of the player that he played against, and also seeing the elo difference. That way we can then average out the average elo difference that the player is playing against. And finally, we're going to create this file, the XIFI file, meaning all the streaks and the frequencies that these streaks occurred, so that we can then create our DataLens dashboard. So the first step is to taking care of the imports. So we're going to import pandas as PD. We're going to import chess pgn to go through the games. We're going to import regex. And we're also going to import OS to take care of the file directories. And now we're going to create the class. So class data manipulator. And now let's take care of the constructor. Init. We're going to pass for now, and as always, let's create the functions first before addressing those. So we're going to need a function here to get the player key, and I'll explain to you in a bit what this means. So def get player key, self player names, going to pass. This function, the whole idea to this is that we're going to have a dictionary with a bunch of names for the player, because inside of the games not always appears as Magnus Carlsen. Sometimes appears as Magnus CA or C.Magnus, or there's a bunch of combinations of names. Not specifically here again in chess.com, but I'm accounting for future uses of these players, because the first chess project that I did accounted for offline games. And Magnus Carlsen, it would appear at like a bunch of different names, so we need to have a way to account for these. So essentially I assigned a key for each player. So let's say Magnus is 2, and then we have a dictionary with a bunch of names for that specific key. Moving on, our next function would be to validate the elo. Self elo string. And the whole idea to this is that in some games we don't have the elo of the other players. In all of them in chess.com we do have the elo for the other player. So let's say here specifically Magnus played as white, and we have this player that played as black. So we have the elo for all of them. But again, in offline games, when I retrieve PGNs from online games from these players, I found sometimes that the games did not have that elo. And because we need a meaningful contribution from each PGN, we need to skip the ones that don't have elo. Because remember, the whole accusation was that he played against a certain type of elo player. If we don't have the elo, we can't use that game. Right, moving on, our next function is to match the player name. Similarly to the get player key, now we need to match the player name. So to do that, we're going to do def match player name, self header name names. So from the names we're going to match the player name. That's all we're doing here. Pass. And obviously, because we're starting out with the PGN and now starting with the CSV from this class onwards, we need to convert the PGN files to data frames. So we're going to do that. Just going to copy the function here. So we are going to convert the PGN files to data frames so that we can then create our own specific data frames, just as I've shown you here before. After converting the PGN files to data frames, now we need to create the player data frame. So to do that, we're going to do def create player data frame, And here, self, then pgn file, it's going to take in the pgn file for that specific player, the player key, and a log file. Same as always, we're going to create a log so that we can account if there are some discrepancies or values, something missing. I'm doing this already because I've done this before. Initially I found some discrepancies, so I then had to address those. This is why I'm doing this already now, because I know the outcome of this. Now it's going to be clean, but initially it wasn't. I had lots of issues that I needed to account for. Let's say it was a game, it was a winning streak, but I wasn't accounting for a tie and so on, if the math was being done correctly. So let's pass this as well. And the next three ones are for filtering data blitz, streaks and details, and the combined frequencies. So same thing. So here we're going to filter the data frame by blitz. Here in this one we're going to calculate the streaks, takes in the DF and the player name because it's for that specific player. And then here we're going to create the combined frequencies data frame. Same thing. So self, name of the player, and then the input file. And same as the other ones, we're going to have a function that does the processing of the files. So def process files, self, going to pass for now. And again, same as the other ones, we're going to have one function that is kind of like the manager. So when we call from app.py, we call this next specific function, and this one, now it's going to call process files, where the actual processing of the files takes place. And then that one uses some of these functions that I created earlier on to take care of some specifics for the specific file. And we can actually start with this one. So we're going to create the necessary data frames, filter the data frames by blitz, and identify and sort streaks. The combined frequencies data frame will come as a byproduct of the other ones because again, it's just a different way of presenting a file that is already created. So let's start. So we're going to do self, convert pgns to data frames, self, filter by blitz, this one, and self, process files. Right, so that way, when from app.py we call the function, we have process data frames and call the other ones to start working on the files. This starts with the pgn that we combined before with the headers, then filters it by blitz, and then we process the files that we mentioned earlier on. So all these files that we mentioned. Now here for the constructor is going to be quite a large one, and the reason for it is that we're going to take in the input pgn file, the combined one with headers that we created before, and now we're going to need to output a bunch of files. We're going to need to output the data frame files, the logs, the filtered by blitz, the streaks unordered, the streaks ordered, the process details, and also the winner names, because we need to account for that specific player that we are creating an instance of this specific class. So here essentially we're going to need a bunch of all these names. So here specifically for the constructor is just literally taking in all these files and putting those in there. Besides the source config, we don't need that anymore because we already have the input pgn file. So we start here. So for the constructor, besides self, we're literally going to copy all these dictionaries. So this one, this one, and keep going doing all these ones. And finally, the winner names. And with this out of the way, we need to now call in the selves. So to do that, it's the same thing, but just it's all the names that we have here essentially, but with self. And in addition, we're going to need a data frames for self. And the reason for it is that later on in the convert pgns to data frames, you're going to actually need to create a data frame for a player. And because we are using classed instances, so we need to have that available. So self data frames, you're going to start it empty for now. So what this means is we are referring to an instance of the class, meaning the data frames will be associated with each object, the instance created from the class. Essentially, this is an empty dictionary, so we can then later on store key value pairs. Think of it like this. Once the pgn is processed and converted into a data frame, so we are going to do that using the create player data frame method that we have here. Then the whole idea is that the result is stored in self data frames for future use, so that we can then later create the filter by blitz and all the other variations of the data frames. And finally, we're going to need the self-player names. This is the one that I mentioned before, where we are assigning a number to a specific list and we need a way to account for that specific player. So to do that, we're going to create self-player names equals to, we have our dictionary here. Our keys are 2 for that specific player, then 1 for the other player, and finally 0 for the other player. Now inside this we're going to put all the variations of the names. I already have this created here because with the logs I went through all the name combos and variations in all the offline games, so that we can then add those specifically to this list. I'm just going to copy this code here so you can see it. So it's Magnus Carlsen, sometimes it's just Carlsen or Carlsen Magnus, and then Norway we have all these variations. And the same thing for Hikaru and the same thing for Fabiano. So we are done with the constructor. And now this is why I ended with this one. This all has this logic coming up like in future methods. It's easier for you when you are creating this, so you can have like a line to keep going. Now because we have this dictionary with key value pairs with a specific number assigned to all the variations of the name of that specific player, now we need to get the player key so that we can then use it later on in the creation of the data frames. So the whole purpose of this get player key is to return the key corresponding to the player name. So you're going to do for key names in self player names items, because this is a dictionary. Now if any name in player names for name in names, you want to return the key. And you also want to raise a value error saying that, say, the player was not found in player names. So to do that we're going to do raise value error f string player, then player names not found in player names. What this means is when we pass in, let's say 2, and the name of the game that we are looking into doesn't have that name of that player there, it's going to raise a value error and saying that the player was not found in player names. This is how I came up with this list, because I kept seeing the name of the player that was not found in player names. So essentially what I kept doing was kind of an iterative process. I kept adding the names that were not found in player names, so that in the end we actually have a list where we have all the names accounted for. And again, just to be clear, this is not about chess.com, this is about all the PGNs of that specific player that I found offline and online as well, not specifically just to chess.com. And now we can move on to isValidElo. The whole idea to this is, remember, for the data frame we are adding a column of the difference between the ELO difference between the players. And to do that we actually need to get the ELOs. So here, essentially it's a check if a given ELO string is a valid number. We are dealing with PGNs and we have a string representation of a number there. So essentially we're going to do return ELO string and call in isDigit. This will check if the given ELO string is a valid number. Now we need to work on the match player name. So for this is for name in names. And let's call it name parts equals to, and now we're going to use regex for this, re split, and now we're going to use this regex. What this means is that for one or more occurrences, this is what this plus means. So we have this stuff here that's going to happen one or more occurrences. What we are looking for is occurrences of either a comma or any white space, so it's this part. So we're looking for in a list of names, if we have commas or white spaces, one or more occurrences, it's going to split those individually. So let's say we have something like this. If we use regex with this, it's going to show something like this. So essentially we have all these occurrences and like repeated names and with a dot and so on. It's going to take every single instance of this one and put that individually in the list. So Carlsen, Magnus, Carlsen, Magnus, Carlsen, with a dot and so on, and remove all the spaces. So to use this, we're going to use R and then put it in there. And then we also need the name. And again, as we have been doing this before, always using lowercase. And now we need to do the same thing for the header parts. Remember, we are accounting for two things. One are these names here, and the other ones are actually the names mentioned in the actual PGN. So you're going to need to do this for name parts and header parts. So it's pretty much the same code, we just use another variable. So instead of names, it's headers. And because we are doing a match, meaning we are asking if this is true or not, we need to account that here with logic. So we're going to do if all parts in header parts for parts in name parts return true. All other cases return false. So the whole idea to this is if the name parts, when they are split using regex, all lowercase, if matches the header parts, meaning the name, the key value that we retrieved before with the names that we have, if any of those names matches the specific header parts, what we have here, return true, else return false. And now we can move on to creating the PGN files to data frames. So let's start doing that. So because we have a bunch of players, we need to start with a for loop. As we create each player, is going to go through all the players. So to do that, we're going to do for player PGN file in self input PGN files and because this is a dictionary, it's items. You can go through all the key value pairs, self player key, equals to self get player key, and for that specific player. So what we're doing here is when we create an object of this class and we want to convert the PGN files to data frame, so with self we have in the constructor we have the input PGN files, and we also have here specifically the player keys. So for that player we need to check to see in all those ones which one corresponds to that specific player. And now the next step is to get the corresponding output paths for the CSV and the log files. So we're going to do that for both. So CSV file, self output data frame files for player, and the same thing for the log file, self output data frame logs, and passing in the player as well. Same as before, we need to ensure if the directories exist. So os make dirs, os path dir name, CSV file exists, okay, true. So if it exists, we don't need to create it, do nothing. And we're going to do the same thing for this one, but instead of CSV file, it's for the log file. And finally, we need to create the data frame and save it. So df equals to self create data frame, and this takes in the PGN file, self player key, and the log file. And the reason for the log file that takes in, it's going to save it. And to do some middle checkpoints, we're going to do these two print statements. I already have those copied here. So essentially we're going to say convert the PGN for, let's say, Magnus and then Hikaru and then Fabiano to CSV. And the same thing, the same for the log file. So for the same player and for the log file of that specific player. Right, let's move on to creating the player data frame. So you're going to start with games data as an empty list. Same thing for not found IDs. And same thing for skipped games. The whole idea to this is, remember, we are taking care also of the log file, and we need to know the games data that was found and the games that were skipped. So when we do the further iterations, we can then address those to see the information that was missing, so that we can then add it to our class. Specifically here, already taken care of that, but when you start from the beginning, you're going to have like a bunch of skipped games and a bunch of not found IDs and so on. So now we need to read the games. So with open bgn file in read mode as in file game count equals 0, because we're starting from the beginning, and then while true game equals chess, and now we're going to use a chess class bgn read game and passing in file. Also, if game is none, we're going to break because we don't have a game. We're going to increase the game count. Plus equals 1. Plus equals 1 is the same thing of having game count. If you don't know that, if you do, great, but if you don't, this is the same thing as having game count plus 1. This is just a more concatenated way of showing the same thing. So instead of having game count equals to game count plus 1, we do plus equal 1. This is all this means. So now we're going to create another variable that's going to take the game headers of this specific game. So headers equals to game headers. And now we're going to add a couple of prints saying we are processing a specific game, and then the white players and then get the white, and the black player got the black, and so on. So here this is what we're doing. So we're showing the game count and showing get white and get black for each player. Now we need to check for the missing hilo. Remember that we are having a positive contribution from each game. We have no purpose of accounting for games that have missing information in it. Specifically when we are averaging out the type of players that a specific player played against. So if we have missing hilo information, we can't use that game specifically here. This is why we're doing this procedure. So we're going to do white hilo equals to headers get, and now the parameters white elo or nothing if that's the case, and the same thing for black. So you just copy this thing over and just change from white to black. So this one is the black side and this one is black. Okay, so this is done. Note here, this is why I'm getting this. So we are doing white elo. Notice how this is the exact match, and this is the whole point to this. White elo or black elo. This is what we're doing. So now you need logic to account for this. So if not self is valid elo, white elo, or not, same thing for black, self dot is valid elo black elo. We have an invalid case, so we're going to print invalid elo in game and identifying the specific games. And to do that, this is why we have the ID. So headers dot get ID and just have some like skipping. We're going to skip this game. Even though we are skipping the game, we're still adding that specifically to the log file. I need to see what's the problem with this specific game. If this is the case, so if not self is valid elo, meaning we haven't found a valid elo either for black or white, skip games, we're going to append the specific game. Headers get ID and then invalid elo and continue. So now we need to check for missing time control. Same thing. If time control with an underscore here, because this is the one that we created, not in headers. Print f missing time control in game, and then identifying the specific game. So headers dot get ID, same thing, skipping. And now, because we found a game that the time control, the one we created, is not in the headers, we need to add that to the skipped games. So skipped games dot append headers dot get ID, and now instead of missing elo, it's missing time control. So missing time control, and same as the other one, continue. Now here, because we are accounting for wins, draws and losses, we need to check what was the color of our player of interest that we was playing in that specific game. So we're going to start with a variable where player color is none. And this is what we're going to do. If self match player name headers dot get white or nothing, self player names player key. If this is the case, then player color is equal to white. Else, same thing. So here, this guy comes here, and it's elif, and instead of white, it's going to be black. One thing to note here, this, when it's empty, it's a default fallback value too. It is not going to assign the player as white when it's here, or it's going to assign the player as black when it's here. It's just to avoid raising a value error. And same as the other ones, instead of skipped games, we're going to account for the not found IDs. If player color is none, you're going to print player not found in game headers dot get ID. So skipping. And same as the other one, we're going to append those to the not found IDs. So print f search for these names, self player games names player key. And now we append. So not found IDs dot append headers dot get ID, and continue. So because this is a negative case, we also need to print if we actually found a player with that specific color. So when it's running through the games, let's say Fabiano Caruana, it's going to say found player as black, found player as white, and so on. So to do that, we're going to do print f found player, and then the player color. And in addition, besides the player, we also need to account for the ID. So to do that, we're going to do game ID string equals to headers. I'm going to get the ID. If game ID string is not none, and game ID string is digit, we're going to convert the game ID as a string to an integer. So we're going to do game ID int game ID string. Else, it means the game ID is none, So we're going to print invalid or missing ID for game and then the game count. And we're going to skip as well. Same as the other ones. Let's continue. Now we need to address the outcome. So the outcome of the game is going to be headers dot get result. This is what's in the headers. Look here, we have the result. And now we need to account for the outcome. So if outcome equals 1, 0, this always comes in order. So the left one is the white player and the right one is the black player. So if outcome is equal to 0, it means that the winner, you're going to headers get and then white. Specifically here, not here. So we have white Magnus Carlsen and black the other player. The result here, we can check. The result here was 1, 0, so Magnus won, white. Even if we didn't have white here, this always comes in order. So now we need to address the other cases. So if outcome equals to 0, 1, winner equals to headers dot get black. Note here the difference. On top we are looking at logic. So if the outcome is equal, meaning logical equal, like Boolean logic, if it's true, if this is true or if this is false, then we're going to assign black to winner. Note this here, this is important. So if outcome the draw, and draw is stated like this in the game, the winner, it's a draw. Else, by any means we have any other case, winner is none. Next step, we need to convert elo ratings to integers. So player elo int white elo. If player color equals white, else int black elo. So we are saying here that the player elo is white if the player color is white, else int black elo. And now here the opponent is the same thing but in reverse. So opponent, and now we just change the colors. So black color elo, if player color white, else int white elo. And now because we have integers of both white and elo side, now we can calculate the difference and then add it to the game data frame. So now we're going to calculate the elo difference. So elo difference. And you might be saying, how can we calculate the player elo difference? It might be positive or might be negative. Here I chose specifically in terms of the main player elo. So it's going to be the main player. Let's say he has an elo of 3000. So if the opponent elo is less than that, so we're going to have a positive difference. If it's the other way around, meaning he play the player that is ranked higher than him, we're going to have a negative elo here. You can choose this as you wish. I just chose the specific order because our subject of interest is the specific player. So player elo minus opponent elo. Now let's moving on creating the data frame. First we will start with a dictionary, game data, that is equal to, and now let's take care of essentially the headers, although here specifically these are keys, but let's start like this. So headers. This one we get directly the get ID. I'm going to have player identification. So not only the game ID, but also the player ID. So player identification equals to self. And the value is self player names, player key, 0. In the initial dictionary, I defined the player names and I just put their names directly, like in normal format. I did that for Magnus, Carlsen, Hikaru Nakamura, and Fabiano, Caruana. All the other ones coming after, meaning all the different positions in the list, are variations of that name. Now let's move on to the outcome. So the outcome of the game, headers, get, and now we need to get the result. The same thing for time control. Headers dot get time control. This is the time control that we created. And now game setting. Meaning if the game was held online or offline. We already know that for chess.com that's irrelevant, but it will be relevant for offline games. So game setting, same thing, we're going to get that from the header. So headers dot get event. So let's move on to the white player and the black player. I already have those copied here, so we don't waste too much time with this. So white and black. The next ones are the player helo. Here specifically because we created that here, we're going to add that specifically here. We're not retrieving that from the PGN. This is why you're using headers to retrieve that from the PGN. The variables that we create directly here, we use those directly here in the dictionary. So this one is players elo. Same thing for opponent elo. And now we can also add the number of moves. And this is a way to use the chess library because it will go through the game, look at the games themselves, look at the number of moves, and we can retrieve that from there. So this is what we're going to do. Number of moves. And then it's len list and game mainline moves. This here comes directly from here. It's going to look to the number of moves that we have in that game ID, and it's going to return the length of that list for us. Let's say it was 46 moves or 47 moves and so on. Now we need the date. Headers dot get what's in there. In our specific case it's date. Add the comma here. We need the winner. In this specific one was calculated here directly, so winner. And also we're going to add the elo difference that we calculated before. So elo difference in terms of player, this is why I addressed this before, is the value is elo difference. We're almost done. Now we just need to append this game data to this game's data. So it's an S in the difference. So games data dot append. You're going to append this specific dictionary. So game data. Same as before, you're going to add a couple of prints here as controls. You're going to see the total number of games processed. It's going to show the total game count. It's going to show the total games included in the data set. It's the length of games data. And you're going to also show the games that were played or was not found. This coming directly from the length of not found IDs and the length of skipped games, what we did here before. So finally, we're just missing writing to the log file the skipped games and the not found ID. So let's do that. So with open log file in write mode as log object log.write f total games processed then just pass in the game count, then just have a new blank line. Same thing for the other one. So log, right? And now let's address the IDs. So F game IDs where player wasn't found. In here we're going to pass in the values, and this is how you do it. So for game ID in not found IDs, you're going to log right F game ID and a new blank line. And here now you're going to say the total games that were processed and included in the data set and the one that were skipped due to missing data. So I have the prints here so that we don't waste too much time with this. So log.write, it's going to say the games included in the data set and the games skipped due to missing data. And same as we did for the not found IDs, we're going to do the same thing for the skipped games. And now we need the reason for it. Remember that we used skipped games and then we accounted for missing time controls and invalid ELOs. So essentially when we are appending this to the specific log, we need to have a reason why that game ID was not appended. So for game ID, reason in skipped games, log right, F game ID, and the reason. And finally, we just need to return the data frame. So return PD data frame, and now we pass in games data. Let's move on to filter by data blades. So to do that, we're going to do for player input path, because we now have the data frame saved and it comes from input path. In self output data frame files items, because this is a dictionary, so self output data frame files dot items. Now we need to load the data frame, filter it, ensure the directories, and save it. So to load, we do df pd.read csv input path. You're going to filter it, so let's call it just filtered data frame. It's data frame, and what you want to filter, just you do data frame inside in the specific thing that you want to filter it by. So df and then df, when it's time control, it's the one that we created, not the initial one. Note here, we have two time controls. It's not this one that has like the numeric value of that game. Let's say it's 60 seconds or 1500 seconds and so on. We already did that before when we went through the method that sees this and checks if it's a rapid or a classic game. We're just interested specifically in this one. So going through all these IDs and just getting the blitz ones. So here, where is it that time control is equal to blitz? If that's the case, this is the cases that we are interested in for our filter data frame. And now we need to ensure the directory. Same thing as we did before. So output path is equal to self data frame files filtered by blitz, and we pass in the player. And now, same as before, we do the OS make theirs. OS path name, output path. If it exists, do nothing. So if that's true, do nothing. And finally, we need to save the filter data frame to the specific path as a CSV. And passing in as parameters the output path, and we are not interested in creating an index. And same as before, we're going to conclude this function by printing that the filtered blitz games for players, let's say Hikaru, Magnus and Fabiano, was saved to that specific output path. Before calculating the streaks, it's important for you to understand my logic behind this. So this will be the end data frame filtered by blitz that we'll be creating when we run the program. For now, let's just imagine that we already created this so that we can then go back and create this the proper way. So this is what we have. We created from the PGN the combined one with all the added headers like the ELO difference in players and all that stuff that we already done. Now we have a data frame from that PGN, and in addition we created the data frame that we filtered just by blitz. And now this is the one that we are interested in so that we can calculate the streaks. This is what we need to have. IDs need to be consecutive. And what this means is that you can play, let's say, in one day and keep playing the next day. So it is consecutive. What can't account for is that if you have an interruption. My thought process was to start counting a streak when you have at least 2 wins. So this would be a case. So you have 2 wins. So we now have a streak with 2 wins and keeps going. And then we will be having streak interruptions. And this is a specific case. We have an interruption here from the IDs. What this means is, because we filtered the data frame by blitz, this means that in between 17 and 27 we have different types of games. So the streak ends at 17. Otherwise we would be counting a winning streak, accounting for blitz games and then rapid games and so on. Maybe let's logic accounting for the different winning streaks that the player had. Specifically here for this project, I just accounted for streaks that are consecutive in specifically just for blitz games. So the specific one, Fabiano Caruana, has a 17 winning streak. Now let's talk about the interruptions. Here, this specifically, it's easy to see because the IDs have skipping numbers in between them. So this one doesn't count. And obviously, because this player won, so obviously this would end the streak. But this one we don't count because we ended at 46 and now we are at 52. And although we have 53 after, but we started with a loss, so this doesn't count. It would count if we started at 53, but then he lost to another player, so this doesn't count. What it does count is when you start with 89. So 89, 90, 91, but then it ends because 94 has a different ID. You get the picture. So now we have 125. This doesn't count as well because the next one is 137. So we only will be counting when the IDs are consecutive. Same as with games from Hikaru, between draws count. And I assigned the rule just for one draw, meaning you have at least 2 wins, you have 1 draw in between, and you keep winning, so you have half a point here. So we say, let's say this one started here. So we have 1 point, we have 2 points, we have half a point, and then we keep going until we have an interruption, meaning another draw or a loss. This was my thought process to do that. So to calculate the streaks, same as before, we're going to start with an empty streaks list, an empty details list, and need to have some counters so that we can reset those in order to counting streaks. So we're going to start with the current streak equals 0. This will be our initial streak counter. You're going to have a start streak ID, just as I explained. You're going to start it as none. Same thing for streak details. So you're going to have streak details, an empty list in the beginning. We're going to need the last ID. Remember that specific case when a streak ends and then the streak jumps ID. So we need to have the last ID so that we can then account for the current streak. And the last one is about the draw. I called it pending draw. And we start this counter at 0. And remember that 1 draw still counts for the winning streak as long as we have 1 only and it's between wins. So now we need to iterate over each row of the data frame. And we're going to use the f.error rows. So for idx row in df.iter rows, current ID is row ID. So we are starting with the current row ID and then assess as we keep going. So the current winner is the winner in that specific row. Now we need to check if the current ID is in sequence or if it's the start of a new sequence. Remember that it needs to be consecutive or sequential. So is sequential. And last ID is none, or current ID is equal to last ID plus 1 if winner equals to player name, if streak start ID is none or not is sequential. This means we need to start a new streak. So if current streak greater than 1, because we start a streak with 2, we still count it in our counter, but it needs to be at least 2. So we start with 1, but it's not a streak. It's saved in current streak, but it's not a streak yet, so we don't append it. We only append it when the current streak is greater than 1, so 2. In that specific case, you're going to do streaks dot append current streak. This adds the current streak count to the streaks list. And the same as the streaks details, remember we're doing two things. We are counting for the current streak and also adding the details of the streak to a details list. And to do that, it's not append, it's the same thing, but it's details extend. Details is our list and we want to extend that list. Streak details. And we need to account the case when that's not greater than 1. If that's the case, it means that the current streak is equal to 1. So now we need to continue for the other cases. So streaks start ID is equal to current ID, streak details, ID, current ID, opponent elo, row, opponent elo, and elo difference, what's in that row, elo difference in terms of player. And now we're going to add the streak details. We are done with this case, so we need to reset the pending draw. So if you are not here, meaning the streak start ID is not none or it is sequential, that means it's a continuation of the current streak. So we are here now in an else, and you are continuing a current streak. So we just increment the current streak plus equals 1 plus pending draw. So what this means is a pending draw coming from here was at 0, but we need to account for a pending draw. Remember that if we have something like win, 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 and then draw, and then we can actually keep going and win, 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 and so on. So the current streak means the current wins and the pending draw. The streak only ends when we have a loss. So if that's the case, we're going to do the same thing but with a little twist here. So streaks details dot extend ID is the ID, opponent elo. I'm going to use df lock as we are interested in the ID. So df, if the ID is equal to this ID, so opponent elo, then values, the first value. And now we need to account also for the elo difference. Same thing, but now it's the elo difference. So elo df lock df id equals to id. This is the elo difference in terms of player. And same as before, values, first value. So here, this one is a curly brace, and we continue, we're missing this one. And now we need to have a range that covers all the IDs that fall between the last ID of the previous streak and the current ID. To do that, we're going to use for ID in range, last ID plus 1, current ID plus 1. We are now here and here. This means that the winner is equal to a draw, and it is sequential, meaning we are accounting for that specific case when we started with a winning streak, and now we have a draw. We need to handle the draw. Essentially, it's in between a streak. So to do that, we're going to do elif winner draw and is sequential. So we're now handling a draw mid-streak. If streak start ID is not none, so we do have some value here, the pending draw is equal to 0.5. Remember that the win counts at 1, a draw counts as a half, and then a null, meaning a loss, counts as 0. And now we're going to do the same thing as we did before. So streak details, we're going to append, and the values are same as before, ID, opponent, elo, and elo difference. Still here, if this is not the case, meaning if streak start ID is none, if that's the case, so this means we have a situation where we have a draw without a proceeding win, and that does not count as a streak. Remember that we have to start at a win, and the streak only starts counting when you have a winning streak of at least 2. If we start with a draw, that doesn't count. This is what we're doing here. So else pending draw is equal to 0. And out of this, we have to complete our else. We have this if, else if, and now our final else. We are now in a situation when it's the end of the streak, meaning a loss or non-sequential ID. So else if current streak greater than 1, streaks append, going to append the current streak, and doing the same thing by extending the details. And now we reset all the counters. So current streak is equal to 0, streak start ID is equal to none, streak details is empty again, an empty list, and the pending draw starts at 0 again. And also we need to account for the last ID. It's now the current ID. So we ended the streak, so we ended with a last ID, and now we are starting with the current ID, assigning the last ID, meaning the end of the last sequence. Now we are starting with a new one, so the current ID starts with the last ID. That way we can correspond to this sequentially. So last ID equals to current ID. And finally, as a failsafe, when we went through all this, we need to handle the last streak, that is, if it exists. And this is simple to do. This is just current streak. If it is greater than 1, just going to append that to the current streak and extend the streak details. So it's the same code we have here. Just get it back. One more and good to go. And finally, we just need to return the streaks and the details. For these combined frequencies data frame, I will show to you how this looks in the end. We have xi, meaning the sequences, and we have the frequency of the sequences. And note here that the counting comes in halves and halves. We have a sequence of 2 and then 2.5, 3, 3.5, and so on. And obviously we're going to have some values at 0 because there was no frequency of at least 1 for that specific streak. Note here specifically, we are not dealing with continuous data, we're dealing with discrete data. The only difference is that we are counting in intervals of f. And you might be saying, but this is a float, this is not int. But the main difference here is that we don't have values in between 0 and 5. That would be a continuous case. This is not the case. We have a streak of 2, this is how it starts, and the next sequence would be 2.5. You can actually hot encode this into dummy variables, and you would just say that this is 1, 2, 3, and so on. And you know that the 1 assigns to 2, and the 2 assigns to 2.5, and so on. But I think this is easier to see. So a streak, it's 2, then it's 2.5, 3, 3.5, and so on. And it's going to go all the way until the last frequency set that player had. In this specific one was 38.5. And for all other players, it will end up like this. So in between streaks we have zeros, but the last one we account for the last xi value when we have at least one fi frequency value. Coming back to our code, how is it that we're going to do that? So we start by first downloading the data set. So data is equal to pd.readcsv, and then input file that comes directly from the argument. So this is done. And now we need to determine the maximum value in the streak column. So max value equals to data streak max. And then we need to generate xi value starting from 2 up to the maximum value with steps of half in between. To do that, we're going to do xi values equals to numpy arrange, and then we start at 2, max value is plus 0.5, and then in steps of 0.5, and then add this to list. What this means is, if the last one is say 5.5, but we don't get there because this one is exclusive of it. So it's 2, 2.5, 3, 3.5, and so on, and 5. The last one we don't get to it. So max value 5.5, the last one would be 5. Okay, just need to add the numpy here as np, and now we are good to go. There you go. So now we need to initialize an empty list to store the frequency counts. So frequency counts as an empty list. And now we need to calculate the frequencies for each xi value. To do that, we're going to do for xi in xi values, you're going to count np.sum data, then streak. In the case where that is equal to xi. So now we need to append the frequency counts with count in it. So frequency counts dot append count. And finally we need to create the data frame with xi and fi. So the result of all this is result. The f is pd.dataframe. And now we're going to assign the key value pairs, meaning the headers of the CSV and its values specifically. So xi values, fi frequency counts. And now we need to define the output file path. Specifically here I have one where we have the specific file path. It's this one inside visualization folder. The only difference is that I prepended the player name before frequency. So we have Fabiano Caruana, then frequencies, same thing for Hikaru, and same thing for Magnus Carlsen. All here that is left to do is to ensure that the output directory exists, same as before. OS make theirs, os bot path their name, then same as before, output file path here, and do nothing if it exists. So true with a capital letter. There you go. Everyone's happy. So finally, we just need to save the new data frame to the CSV file. So we already know how to do this. So it's results, df to CSV, output file, and we are not interested in creating an index. So index false. And same as before, you can use the fancy printing thing saying that the CSV was created successfully for that specific output file. We're not done yet. We're almost done. So now we need to create the logic inside process files. And here we're doing a couple of things. From here we are using all the stuff that we have done here so far so that we can then process the files. We're going to start with 4-player key, same as before. Input file in self data frame files filtered by blitz items. This is what we want to do. We want to read the CSV and sort the values. The whole idea to this is that, like I was explaining in the beginning, we have a PGN to the data frame, that is done. We need to filter the data frame by blitz, okay, that is done. We need to get the consecutive winning streaks ordered by games. Note here that the text that I have here, it's ordered by game, so the IDs of the games, but the sequences themselves are not ordered. What I mean by this is that we have, like, let's say 2, then 4.5, and then 6, and then 1. What we're doing here essentially is just the consecutive winning streaks, but ordered by number. So 2, 2, 2, 3, 3, 3, and so on. I'm actually going to show this specifically so you can understand the idea. So let's say this one, we have process streaks and ordered, meaning we have like the IDs and all that. We just skip that because all the IDs and all that stuff is in the details. But here we have 17, we have 5, 10, 3, and so on. And in order to use statistics, we need to have this ordered. Most likely, most programs already order the stuff in the beginning, but I don't like to depend on anyone really, so I like to do this by myself. So to do that, we're going to order essentially all the same streak. This is exactly the same streak, but it's ordered from the min to the max value. This is what we're doing. So coming back here, so 4-player key input file in self data frame files filtered by blitz, and then items, because this is a dictionary. We're going to read the df, so pd read csv, the input file, and now we're going to sort the values by id. So df sort values by id. And then we're going to reset the index, drop true, because otherwise we'll be keeping the previous index in this one. It will be confusing. So to be clear, we're just interested in the values, that's all. So true. So when we are reading initially the data frame, we need to use the correct name for the winner column. To do that, we're going to do player name in, I like to use long names, winner column equals to self winner names, and then player key. And now we need to return the streaks and the details. So streaks details equals to self calculate streaks and details. And we're going to pass in the f, the player name, in winner column, and we are done with streaks and details. And now let's move on to the unordered versions. So streaks df equals to pd.dataframe, And then we're going to define the header. Specifically, we're just interested in naming it streaks, that's all, because we have the file name for that specific player. So streak, and then the value of the specific key is streaks. Now, same thing as before, we're just going to process it directly to a CSV. So streaks, nothing new here. The f dot to CSV. Now self processed streaks unordered, so it's the first version I was explaining to you a bit ago. So player key, and we are not interested in adding an index, so false. And now we're going to do the same thing, but for process details. So details, the f is going to be pd data frame details. And again, same as the other one, details the f to CSV, and to pass in self processed details, player key, index false. And now let's move on to the ordered streaks. So streaks, the f sorted, let's say call it min max, streaks, the f sort values by streak, and ascending true. So it's a streaks again, this is self-explanatory, and we are just sorting those directly by value. And same as the other ones, now we're going to add all the stuff to the CSV. So streaks, df sorted min to CSV, same as before, pass in self process streaks ordered, player key, and we are not interested in a new index. And finally, we need to create the combined frequencies data frame. So to do that, we're going to do self create combined frequencies data frame. We're going to pass in the player key, so we'll know if it's Magnus, Hikaru, or Fabiano. And then self processed streaks ordered with the player key. Right, and we are done with this one. So now I'm just going to delete all these values here from the CSVs so you can see that this actually works. So get this out of the way, get this as well, bye bye, and this one goes away as well. So get these out and get these out. So now here at app.py we can run this. So as you can see, it's going through all the players and all the stuff. This is going to take a while, but in the end we'll start seeing this becoming populated. So the CSVs, the visualization, and the logs. And we are done. Note here, so we have the process data frame with all the information. Then we have the filter data frame just from Blitz. Then we have the streaks unordered, we have the streaks ordered, and we have the streaks details. So ID, opponent ELO, and ELO difference. We have this for all the players. And then specifically for the visualization, so that we can then later use this in our next video in DataLens, we have XI and FI for each of these players. And in addition, we also kept this handy and dandy, our logs, saying that the total games processed, the game IDs where the player wasn't found, the total games included in the dataset, and the number will match. And also we have the games skipped due to missing data, so we have none. Initially this was not the case, but now it is, because it took a while for me to get through this in order to get all the games included with the missing data. Welcome back. In this next one, we're going to see how we can incorporate stockfish analysis, meaning the accuracies of the games, into our data frames. So the first step you want to do is to go to stockfish.org, then download, and you want to download the bottom one, so this one. As soon as you're done, you're going to open the folder, and you're going to drag this folder directly to where you have your external module. So external, you drag the folder into there, so it's a stockfish folder, and then you're going to have all the stuff in there. And we are only specifically interested in the executable file. So how is it that we're going to use this and then retrieve the accuracies for each game? So let's go through this. The first thing you want to do is to do import chess. This is a core functionality chess for board and game. The second one is import chess.engine. This is to interact directly with Stockfish. The third one is to import chess.pgn, so you can read the pgn files. We're going to import math because we need to do some math here. We're going to import OS to deal with file paths and all that stuff, and also importing pandas as PD, same as always, import pandas as PD. So now we need a path to Stockfish binary. You're going to do that right here. So path, just copy the folder that I have here. So input Stockfish, you literally copy this file here. So copy path and just add it directly here. I already have this here. I'm just going to add it again for you to see. There you go. Now let's move on. Now I'm going to show you specifically how you can do this for each player. So let's do that. So let's hard code the specific player. Let's say selected player equals to Magnus Carlsen. You're going to change this to whatever name you want of the player that you want to analyze the accuracies from. Then you're going to define the accuracies path. Again, the same thing. We have the gigantic dictionary. I'm just going to copy the whole thing over here so you can see. But same as before. So we have a dictionary, we have an outer dictionary, we have the inner dictionary, meaning the Magnus Carlsen is mapping PGN and CSV keys to their specific values, specifically where the PGN header is and where the accuracies of the file, the end file that you want. This is not the end accuracies that we have in visualization. This is specifically the accuracies for the PGN games for each specific player. And now we're going to define the paths for the selected player. So to do that, we're going to do input, PGN, and then accuracy paths, then selected player. And we are interested in the PGN. And now the output accuracy CSV. Same thing, so accuracies paths, and now selected player. But now we are interested in the CSV. Now we are going to have a couple of functions here. We're going to load the processed IDs and we're going to save the accuracies to the file. So let's do that. Def load processed IDs. If OS path is file, output accuracy CSV. Want to try the following: df equals to pd.read CSV, output accuracy CSV, and we want to return set with the df ID. So return set df ID. Now, except we're going to add some errors here, meaning like say the warning the file is empty or error reading the file. So let's do that. So except pd errors empty data error. You're going to print f warning the file and then the file itself, output accuracy CSV is empty. And then except exception SE, you're going to print f error reading output accuracy CSV, and then pass this as a string E. And then we want to return the set. With this out of the way, now it's time to save the accuracy to a file. So how are you going to do that? So def save accuracy to file. You're going to pass in game ID, white accuracy, and black accuracy. And now to save the accuracies, this is important because this takes a bunch of time to do, because it's going to go through all the games and takes a while to do that. So the whole idea to this is you're going to append each accuracy that is calculated, but let's say at the end of the day, at the end of like a couple of hours, you want to close this down, like stop the execution. When you start it again, it's not going to overwrite the existing ones. It's going to append new ones to the existing file. So to do that, we're going to do with open output accuracy CSV, and now in A mode, meaning append mode. So SF object. And now the whole idea is to write the header only if the file doesn't exist yet. If that's not the case, we will not overwrite it. If not file exists, F write, you wanna write ID. We are interested in the white accuracy and the black accuracy. Then just do it like this so we can have some space. And now it's time to actually write the accuracy data. So to do that, we're going to do F write, F game ID, white accuracy, and black accuracy. Give it some room as well. And now we need to do some math here. And this math doesn't come from me specifically, it comes from Lichess specifically. So these are two functions specifically to calculate the accuracy based on Lichess. I just put those formulas directly in these two functions. So this is what this means. A centipawn is essentially a cent of a pawn. The whole idea is that when you play against a player, Stockfish is going to evaluate like where you have like the piece position. You're going to have the number of pieces that you have. It's going to account like for a bunch of stuff, and it's going to account for what's called a centipawn. This is why when you see the eval bar, it goes up and down in favor of the black player or the white player. This is coming from Stockfish or whatever the chess engine that is using. So it's going up, it's going down. That is not returning a percentage to you. What is returning to you is an evaluation in centipounds. So centipounds go up or centipounds go down. So this is the formula directly from Lichess when it's calculating centipounds. And the whole idea for us is we need accuracy. We need a number from 0 to 1. In order to do that, we need to convert the centipounds to a win percentage. And this is the formula to do that. And now we need to actually calculate the accuracy. And you might be saying, weren't we doing this here before? No, because you need to calculate the accuracy percentage based on the change in win percentage. So it's two centipawns if you look at this. So it's the win percent before and the win percent after. That's the whole idea. And the formula for accuracy, it's this one. The whole thing that I noticed that was missing is that we need to clamp the accuracy between 0 and 100%. Otherwise, you might have some like weird values where the accuracy actually goes above 100%, and that is a mistake. So here, in order to account for that, this is why I have max, where essentially I'm like cramping down the values in between 0 and the max accuracy of 100%. And now with the math out of the way, this is the actual function that actually calculates the accuracy for white and black. So def get accuracy, game ID. Now we're going to initialize the Stockfish engine using the path to the Stockfish executable. So to do that, we're going to do with chess engine simple engine dot pop open UCI. Note this UCI, you're going to see this a lot. UCI means Universal Chess Engine. It's a protocol for communicating in between the chess engines and the actual interfaces that provide like the visual board and on. So here, let's continue. Input Stockfish as engine. And now we need to initialize the board, the white accuracy, the black accuracy, and the total move count from both white and black. So board equals to chess board white accuracy total, black accuracy total, white move count, and all those other ones. I'm just going to put those here directly. So all those start at 0. And now, because our game was already played, now we need to have Stockfish to actually play the game and then evaluate it. So to do that, we're going to do for move number, move in enumerate, game mainline moves, board push, move. The whole idea to this is it will update the move to the next position. And here, you're going to define some time for Stockfish to evaluate each move. For purposes for you to actually see this working, I'm going to deliberately place a low value because otherwise it will take like forever. Think about it, we have like 50,000 games from Hikaru, will be here forever. So just for the sakes of this presentation, I'm just going to put like this super fast time that will give Stockfish to evaluate each move. So now we need to determine the current size to move, and since white starts first and black starts after, so essentially we have this situation where it's even or not. So to do that, what we're going to do is white turn equal to move number, and then this will yield 0 because it's even. So this means that the move index starts at 0. So white are the even positions. Now we're going to analyze the position before the move using Stockfish and get its score. So info, before, engine, analyze, board, chess, engine, limit. I'm going to limit it to this specific time. Again, I'm just doing this for the sakes of this presentation. In reality, you would give it much more time other than just pretty much no time to evaluate the positions. So score before, info before. Now we want to get the score. And now this following line will retrieve the centipoint score from Stockfish evaluation. The whole idea is, as I explained before, it will result for that specific position before a move. The whole idea to this is that the score is only accessed if it is available and valid. Otherwise, we would get like a bunch of zeros and nones because Stockfish didn't evaluate the position. So to do that, we're going to do centipoints before, score before, relative score, if score before, and score before relative, else none. Then we need to convert to centipoints to percentage using the lichess math. So to do that, we're going to call the function that we created earlier on. So it's win percent before equals to centipoints win percentage. And now we're going to pass in centipoints before. And now we need to do the same thing, but analyzing the position after the move. So info after equals to engine analyze, board chess.engine, and again I'm going to limit it deliberately just for the sakes of this example. I cannot re-emphasize this enough because otherwise we'll stay here forever. So score after equals to info after, then get, I want to get the score. So now doing the same thing but centipoints after. Score after, relative score, Just going to momentarily place this here so I can write if score after and score after dot relative else none. So just going to place this here so I don't get the error. Right, so now we need to do the percent after. So to do that, we're going to do when percent after equals to centipons to when percent, and now centipons after. And now this is the point where you actually calculate the accuracy of the move. So to do that, we're going to do accuracy equals to calculate accuracy. And now we're going to pass in the win percentage before and the win percentage after. Then we're going to add the cumulative accuracy to the respective player. So if is white turn, white accuracy plus equals accuracy. White move count plus equals 1. So essentially what we're doing here, we are moving the piece. We get the accuracy and then we move the piece. And you're going to do the same thing when it's black's turn. So else black accuracy plus equals accuracy. And then we're going to move the piece. So black move count plus equals 1. And now we need to average white and black's accuracy, which is essentially the cumulative accuracy over the total move count. So we can average it out. So average white accuracy equals to white accuracy total divided by white move count. If white move count is greater than 0, else 0. And we're going to do the same thing, but for black now. So average black accuracy is black accuracy, total accuracy for that player over the total move count, if the move count is greater than 0, else 0. And finally, we need to return the average white accuracy and the average black accuracy. So return this fella and this fella. There you go. This is a function that will be useful to you because this takes a ton of time to do. And when you start processing a file, it's important, like when you conclude it. And now this is a function that I created that will help you with checkpoints. The whole idea to this is that if it takes you, let's say, 2-3 hours or more, and you have to stop the execution, when you run it again, it will start from the last processed checkpoint. It's not to start from the beginning again. So to do that, we're going to do def load last processed game. The whole idea to this is to load the last processed game ID from a checkpoint file. Checkpoint file equals to output accuracy CSV plus, and now we have a checkpoint. And our checkpoint needs to go somewhere. So to do that, we're going to do if os.path is file, checkpoint file as an argument. This fella comes here. Now we're going to try with open checkpoint file. This fella here comes here in read mode as f. We want to return f.read.strip. And let's add some exceptions here. So except exception as e. I want to print error reading checkpoint file. Let's add this here so you can see it in as a string. Else we want to return none. So now we need to save the last processed game. To do that, we're going to do def save last processed game, pass in the game ID. So this part is the same. The only difference now is that we are going to open the checkpoint file in write mode. Try with open checkpoint file. In write mode as f object, and now we're going to write, so f write game ID. And now the same with the exceptions, so just going to copy the thing here, because it's the same thing. So copy this and accept exception SE, writing checkpoint file. And finally, let's run this inside main. So def main processed IDs, load processed IDs, last processed game equals to load last processed game, no arguments. And now we're going to do the same thing but in reading mode. So with open, we're going to read the PGN file. With open, input PGN in read mode, then encoding equals to UTF-8 as PGN file. Now we're going to start a counter, so our game index equals to 0, and while true, game equals to chess.pgn.read game, and we're going to pass in the PGN file. If game is none, it's the case where it doesn't happen, so we're going to break. And now outside here, we're going to increment the index plus equals 1, and the game ID is going to be equal to the game gathers. We're going to get the ID, otherwise it's an unknown game index. So game headers dot get ID f unknown game index. And now this is the part that's going to be useful, because if a game was already processed, we're going to have some logic here to say that that game is being skipped because it was already processed. So to do that, we're going to do if last processed game and game ID is greater or equal than the last processed game, I'm going to print f skipping game ID. So here we're going to continue, and we're going to do the same thing for the game ID. So same thing, game ID in processed IDs, skipping game ID already processed. So now we actually need to process the game. These are the situations where the games were already processed. Now this is a part where we actually process the game. Processing game ID, pass in game ID, white accuracy and black accuracy. Now we want to get the accuracy, game and game ID. Now if white accuracy is not none and black accuracy is not none, so same, you want to save the accuracy to file, and you want to pass in game ID, white accuracy and black accuracy, and then we want to save last processed game, passing in game ID. Else, if that's not the case, You want to print, say failed to compute accuracies for the game. Let me just copy the thing here, just text here. Right, and finally, just missing name equals main and run main. Alright, so let's run this. So here you can see you already have some game accuracies played here. So we have ID, we have white accuracy and black accuracy, and these ones are actually quite high. I wouldn't be surprised because yeah, these are grandmasters, so they are very high in their accuracy when they play in their games. And that's it. I'm just going to stop here when it runs through this one. And note here what it's going to do. So I stop the game deliberately here, and now when I run it again, notice what it's going to do. So it's going to skip the game that was already processed, and it's going to start processing from game ID equals 5. So it's going to keep going in the next game. So it takes a while, and then it keeps going. Same, just going to show this to you one more time for you to see that this works. So we're going to run this again. It's going to skip the games that was already processed. Now it's going to start from ID number 6, and you can see this happening here. Welcome back. In this next one, we are now going to do analysis on the XIF file, and also going to save the box plot, which is a graph that we're going to need, so that we can then load it to DataLens. So the whole idea to this is that we're going to end up with a box plot for Fabiano Caruana, one for Hikaru, and one for Magnus. And in addition, we're also going to have text as well in regards to our analysis of each player. So let's do that. So first step, we're going to do pandas as PD. We're going to import numpy as np. This is nothing new here. You go import matplotlib .pyplot as plt, and import OS for OS operations. Now you're going to need the input file paths and the output folder. So to do that, I'm just going to copy this over. There's no point into actually writing this. What I'm doing here is essentially the input files. Again, it's another dictionary for Magnus, Hikaru, and Fabiano. And the input files are the Magnus Carlsen frequencies, so the files that we already have inside of the visualization folder. Let me just close this here so it can be easier for you to see. So we are interested in these 3 files. This is the files that we're going to work with and actually do our statistical analysis here. And then we're going to also define the output folder so that for the pictures, we're going to save those directly here. So let's do that. So now that we have the file paths and the output folder, so we need the function to calculate summary statistics and then save the plot. So def summary statistics gets in the df and player name, then x equals to df xi. Remember that we have xi columns and fi columns, so we are essentially separating the streaks from the frequencies. So xi here, then y, then f equals to df fi. So with this out of the way, now we need to repeat each streak according to its frequency, because remember, let's say we have 2 and then we have 40. What this means is that we have 42s. So there's a function that we can use from numpy called np repeat. So the full data is np repeat x and f. So now we just need to calculate the scripted statistics. So mean, round np mean, full data, and then with 2 decimal places. Same thing for median, round np median, full data, then 2 decimal places. Mode, this is a little different, so it's x max frequency, id x max. And now we're going to do some percentiles, and because this data is highly skewed, as you are about to see, so we need to account for percentile 1 up to percentile 99, so that we can see all the streaks accounted for below a certain percentage value. I'm going to do the first one for you to see and then copy the other ones because these are all the same, just changing the percentage. So np dot percentile full data 1, which is 1%, and then with 2 decimal places because we are rounding this. I'm just going to copy the other ones for you to see. This is the same thing. So 5, first quartile, second quartile, and third quartile. Also, you know that this is a median because this is 50%. This is 25, and this is 75, and this is 99. And the reason again I did this because the data is highly positively skewed. So then the highest streak, so the max, np.max, passing in x, and then we also need the frequency of the highest streak. Think about it. Let's say you had a winning streak of 50. How many times did you have winning streaks of 50? Right? So frequency of highest streak equals to, now we need the f, not the x, and then x inside the idx max. Now we just need to print the summary statistics. I'm just going to copy this over. So it's the same thing, so just printing and then just passing in the player name and then the mean, median, mode, and percentiles and all that. Moving on, now we're going to extract the outliers and print the box plot. So I'm just going to copy the code. It's easier to, because otherwise we'll stay here forever just to printing some box plot. So figure and x subplots, we're going to define the figure size. And then after all this, we're going to extract the outliers. We want to know the lowest outlier and the highest outlier. We want to know specifically what's the value of this fella and what's the value of this fella, and want to have it appearing here. And then this is the key point. We want to save the plot. And the key for this is the same thing. So it's output file, everything that we have done here before, and then having the extension. And then we're just going to define the depth per inch and the output file. And instead of plt show, it's plt save fig. So just going to print saying that the plot was saved as the output file. And then we're going to close it. So if I take this out of here, so you to see. So when I run this, you're going to see the pictures being saved in the visualization file. 1, 2, 3, there you go. Welcome back. Now finally that we went through all this trouble to retrieving the games, like processing the PGNs, like creating like a bunch of CSVs and having like our statistical analysis of that player, now we actually have to show the data to people. To do that, I use Yandex DataLens. You can connect and create your account, so nothing new here. So Evil Math Cat, this is me. And then when I open this, I'll explain to you how this works so you can do this by yourself. So here, I'm going to show you actually what I created for Magnus, Hikaru, and Fabiano, so you can see what we have here. So I created this dashboard. So you see like the Magnus bar plot, the Magnus scatter plot, and they have like a pie chart. We have a xi and fi that we calculated in Python, and actually have some streaks selectors. So if you want to check streaks, let's say above 10 or 20, let's say 20, we put the number here. So when we do this, it's going to update the values, and now the minimum value is 20. So this is pretty cool. And the other thing, so we just need to click outside of the box. So this is going to update it immediately. This is the part that we've done when we created the text analyzing the streak of each player. So I essentially copied this information here and just add it here specifically for each of these players. So now you can actually show the streak for each of these players. So we have one for Magnus, we have another one for Hikaru. I'm going to show this to you. And finally, we have another one for Fabiano Caruana. Now, here are the ones that I've shown you. Obviously, this is one per player. And you might have a situation where you have like a bunch of players in just one data set. This is the code for you to do that if you don't know. So essentially here, the version of this that I've shown you on DataLens. Now here, what we are creating is a data set that has all the players combined. And what I have for the ID column is the name of the player. That way we'll create one unified dashboard for all the players. So when you run this, and then you get the CSV, now here on DataLens, in this version you just have one dashboard. That way you have the information combined, and the only thing that you need to do is just to select the player. From the perspective of the CSV, what we essentially just have as difference is just we have ID and we have the name of the player. This is limited to 1000 rows when it's showing the head of the dataset, but the following ones have Hikaru Nakamura and the other one has Fabiano. That way, when you go back to the dashboards and you have this blitzkrieg analysis, which is my final dashboard, now here you can select by ID, and I'll show to you how this looks here. So here specifically what I did, we have the combined data set, and you have a field called ID, and you have the operation equal to, you have a default value, but then it looks for the other values that we have in the ID column so that you can then select it. That way you have one value for Hikaru, we have one ID value for Fabiano, and one for Magnus Carlsen. I will show to you how this is done. So you're going to go to dashboards, you want to create a new dashboard. I'm going to create a new workbook right here. Let's call it chess 2. I want to create it. And now you want to click it, create. Now you are at your new dashboard. This is a dashboard for one player. So you need a data source in order to have this specific dashboard for that player. To do that, you're going to go to connections. You want to create a connection. And a connection comes from multiple sources. It could be Postgres, MySQL, there's a bunch of them you can use here. So our specific one is just files. So here you're going to upload a file, let's say Fabiano frequencies, just call it 2. So it's going to upload the file. And now you have Fabiano frequencies here. So you want to create a connection. You want to choose the workbook. You want to create a new connection. Let's call it Fabiano frequencies Cs2. You want to create the connection. And now note here on top, you want to create the data set. So keep going. You want to create the data set. And now you want to save it. You want to save Fabiano frequency Cs data set. So you want to create. And now you want to create a chart. So you create a chart here. And here, this is how you do it. So let's say a column chart. So Xi's come here and Fi's come here. And now you have your column chart. You can actually do a couple more things here. You can actually add labels. So measure values. And now you're going to see the ticks on top of each one. And in addition, if you notice here, we have like a bunch of zeros here. We can actually filter those. We can go to chart filters. And here, specifically, this is FIs. We want to remove FIs from here. You want to select all of them and just remove 0. So now when you apply the filter, you're going to remove the zeros from here. You have the ticks on top of the graph and the graph is done. And now you just need to save the graph. So we want to save. So now at your objects, you have your connection, you have your data set, and you have your chart that we have just created. But you still need to create a dashboard for Fabiano. So let's do that. So you want to create a dashboard. And now this is where the place where you actually add the chart. So you want to check the select button. You want to select the Fabiano column chart. And you can actually give it some additional description, some writing, some stuff here that is important for you. And then you're going to add it. And now here, this is where you have the graph. You can resize it, the size that you want. And then you're going to save it. You can actually add some header here saying bar chart. And then you're going to add. And now you actually can move this and have like the bar chart on top of the graph. So now when you save this, let's say Fabiano chartboard, you want to create it. And now you're good to go. If you want to keep going, this is the same thing. You want to go to charts. You want to create a new chart wizard. You want to choose your workbook. You want to create. And then instead of column chart, let's say it's some other thing. So let's say it's a scatter chart. So here, same thing. So you want to select the data set. You want to select this one is going to go here. This one is going to go here. So you're going to now showing this. You already seen this about the value 0, so it's the same thing. So FIs, select all the stuff, remove 0, apply a filter, So now you have your scatter chart. You want to save it. Let's say scatter charts, and you're good to go. And now you want to add the new chart that you have just created. So you're going to select, and then it's the second one that we created. So scatter chart, just add, and now you have it here, and you can resize it and just do whatever you want that makes it like better for your presentation. And finally, you can come over here and then grant it public access. And the whole idea to this is that when you're actually sharing this presentation with someone, you can give him a link so that people can watch the dashboard. So you want to make it public, put some link text here, just referring for yourself. And when you copy the link, just going to apply this. Now, when you come here and put in the value, now you're going to see the dashboard that you have just created. And there you go. I hope you enjoyed this video. Remember to subscribe and click that notification bell so you can know when I make more videos like this. Peace.